Ready, ready, ready. Online, can you hear me? Can you see the screen? Just checking. Online, can you hear me? Can you see the screen?
Yes, we can.
Okay, beautiful. All right. So it's raining cats and dogs. Wants to stall our progress, but nothing can stop this train. Math train. Because more maths equals better maths every time. All right, guys. So we're at day 4. I want to finish off this strategic approach to the multiple choice. And so today we're going to be doing matrices. We're going to be doing matrices. We're going to be doing matrices. Then we're going to go all the way down. And we're going to do matrices and vectors first. And then we're going to go and do functions. We're going to do functions. We did statistics yesterday. We're going to come all the way down here. And we're going to come here. We're going to do relations, functions, and graphs. We're going to take a break. And then we're going to finish off after the break. After functions, we're going to finish off with geometry, trigonometry, inclusive of transformation and so on. So that is the plan for today. And then, as you know, tomorrow, we're going to be doing 6 papers in 3 hours. Tomorrow, 6 papers in 3 hours. Tomorrow. And then on Thursday, we're going to do 6 papers again. Face to face. You're coming here face to face. Face to face tomorrow. Tomorrow and Thursday is face to face. 6 papers in 3 hours. All right. And that is the exam strategy. All right, guys. So let me go back up to matrices and get started. Matrices and vectors. So remember, the whole objective here is to get ourselves familiar with the question, and in particular, we want to look at how CSEC is making changes to the questions and be mindful that those changes are being made and not go there and depend on memory of questions, such that if they make those small changes, we are still able to do the questions. All right, we have seen the pattern so far that what they are doing, they are setting back the same question really, and they are reversing the information. So some questions, what they do, they put the answers in the questions and vice versa. They put the questions in the answers, all right, from paper to paper. All right, let's go. First question here. This is matrices. And this means the modulus of the matrix is 0. This is another way of writing the determinant. That means the determinant of A. So the determinant of A is 0. That's what this means. The determinant is equal to 0. If the determinant is equal to 0, it means that A has no inverse. The matrix has no inverse because the determinant is 0. That's why it has no inverse, right? And when it has no inverse, it is said to be singular. A is singular. So the answer is this one. A is a singular matrix. So if, for example, they might change this question now and put, for example, the determinant of A equals 1. It means then that the matrix now be non-singular. You get me? So instead of putting the matrix, the determinant equals 0, they could put a value other than 0. If they even put 0.1, or put the determinant of A equals 0.1. 0.1 is not 0, and so this would mean that the matrix is non-singular. Non-singular. All right? So any value other than 0, the matrix is non-singular. Once the determinant is 0, the matrix is singular. So look out for that. I'm expecting them to set a question where the answer is going to be non-singular. In that case, the determinant is not 0. Another thing they might say is that they might tell that the A has no inverse. If they tell that the matrix has no inverse, then it also means that it is singular, and it also means that the determinant is 0. So they can give you any one of these three things. Any one of these three things. Any one of those three things means the other two. So because they tell us that the determinant is 0, it means that there is no inverse and it is singular. If they tell that it has no inverse, it means that the determinant is 0 and it is singular. If they tell that it is singular, it means that it has no inverse and the determinant is 0. So anyone they give you, it means the other two. All right, enough time on that question. Next question says, two matrices A and B are conformal for multiplication, A times B if. Remember, matrices multiplication is possible. That's what they mean by conformable, possible. Only when the number of columns in the first matrix is equal to the number of rows in the second matrix. That's what they're looking for. The number of columns in A, the first matrix, must equal to the number of rows in B. Mute your mic, please. Somebody mic is open. See here, the number of columns in A is equal to the number of rows in B. This is what you're looking for, guys. Pay attention to the details. The number of columns in the first matrix, which is A, must equal the number of rows in B. See here? The columns in A must be equal to the number of rows in B. All right, let's continue. The determinant of the identity matrix is, now remember, the identity matrix is the matrix 1, 0, 0, 1. And the determinant of the I matrix, the determinant of the I, and this matrix is also given the letter I, identity I. The determinant of I would be this product minus this product. So it will be 1 minus 0, which is 1. You must know that the determinant is 1. Determinant of the I matrix is 1. The identity matrix is 1. Let's go back for the blue marker. Next question says, this is a matrix A. Then what is the order? Instead of, they could have used the word size. Size and order mean the same thing in matrices. The size of the matrix is the order of the matrix. It is given as the number of rows by the number of columns. That is how you state the order or size of a matrix. You state the number of rows first by the number of columns. Rows by columns. That's how you state the order of a matrix. So this matrix now, it has 3 rows. Remember, the rows are the horizontal data. So it has 3 rows. 1, 2, 3. 3 rows. And it has 1, 2, 3, 4 columns. 4 columns here. So therefore, it is a 3 by 4 matrix, rows by columns. It becomes a 3 by 4 matrix. 3 by 4 is the answer. Because it has 3 rows, 4 columns. Look here, we don't want to get these questions wrong in the exam. They don't make any sense. They're too easy. We must get these questions right. Okay? Straightforward questions, these. Let's get them correct. Let's not give them away. This one now. X is this matrix, Y is that matrix. What is the order or size of the matrix product XY? When you multiply XY, what is the result? Let's set it up. So we can remind us, we don't know what they're going to set in. First, the X is a 2 by 3 matrix. 2 rows, 3 columns. So this is a 2 by 3 matrix. 2 by 3. Instead of at times, I can put the word by there as well. This one has 3 rows and 2 columns. So this one is a 3 by 2 matrix. A 3 by 2 matrix. So this is the X size of X, this is the size of Y. So we are multiplying a 2 by 3 times that 3 by 2. Because the number of columns in this matrix is 3, and the number of rows in this matrix is also 3, they are equal. It means that the matrix multiplication is, I ask you to leave now. It means that the matrix's multiplication is possible, because the number of columns in the first matrix here is equal to the number of rows in the second matrix. The resulting matrix will take the number of rows from the first one and the number of columns from the second one. This is what forms the resulting matrix. The resulting matrix will have that order. That's a 2 by 2. 2 by 2. It takes the number of rows from the first and number of columns from the second to get the result. I put Y, result. A resulting matrix. So we're looking for a 2 by 2, which is right here. The result of XY is going to be a 2 by 2. But I understand that. Everybody good with that? Everybody okay? Online, everybody okay with that? All right. Let's continue. Another question here. It says this matrix is A, this matrix is B. The same 2 matrices are given now. Well, it's A and B, but they call them something different now. They call them X and Y here. This time call them A and B. They're asking us something different. They say, what is the product of the matrices? Which of these will be the product of the matrices? We just need to start it. Remember, the answer is on the paper. So we start as if we're multiplying them. All right? Let me set it up for you now. So multiplying 1, 3 minus 3 with 3, 0, 5. And multiplying that with the 3, 0, 2, 1, 0, 5. Let's write this better. 2, 1, 0, 5. And the answer is a 2 by 2. That's what we got here now. 2 by 2. Same 2 matrices. And you show them here. These are showing that the answer is going to be a 2 by 2. So resulting matrix is going to be a 2 by 2. So it's as if we're working it out. The 2 by 2 is going to have 4 values. Here, 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 and here. We just need to work out at least 2 of them and see which one of these 4 matrices match those 2 values. So let's say we're working out this value first right here. That value is positioned in the first row and the first column. So to get it, it means that we're going to multiply this first row by this first column. Because you always take the rows from the first matrix and you always take the columns from the second matrix when you're multiplying matrices. All right? So this first value right here, or you multiply the matrices. You multiply them first element times first element, second element times second element, third element times third element. That's what we're going to do to get this figure right here. So let's work it out now. So it's going to be first element times first element. That is 1 times 3 is 3. Then second element times second element. That's 3 times 2 is 6. Then third element times third element. That's negative 3 times 0 is 0. So let me expand this matrix a little bit more. 2 by 2 matrix. Let's make it a little larger. So the first value is a 9. So the first value is a 9. So let's write it here. The first value is a 9. But this is going to work out to be 9. You can see that. So it means that the answer is either here or here. One of those 2. So we basically eliminated this one and eliminated that one. So all we need to do now is work out the second value here. Because if you get the 12 is this one, the negative 12 I mean is this one, and if you get the 18 is that one. So let's need to work out this second value here now, this one. That value is in the first row and the second column. So to get it to multiply this first row by this second column. Remember how you multiply them? Let me use the blue and show it. First element times first element. Second element times second element. Third element times third element. That's how we multiply them. So let's work it out now. All right? So let's work it out. So it's going to be first element times first element. That's 1 times 0. That is 0. Then second element times second element. That's 3 times 1 is 3. That's plus 3. And then third element times third element. That's negative 3 times 5. That's negative 15. So that's negative 15. Let me just stretch this bracket over some more. And you can see that this works out to be negative 12. 3 minus 15 is negative 12. So I don't need to work out anything else. This one has negative 18, so that one is wrong. The answer is here, negative 12. So don't have to go any further by a process of elimination. So the answer then is A. But go to that? But okay? All right, we just need to work out 2 values. All right, that finishes that one. This one now, nice and easy. If A is this matrix, now what is 3A? 3A means you're going to multiply each of these values by 3. Let's look at it. 3A is going to become, you multiply each of the values by 3. So this line becomes, multiply this by 3, we get 3. And you use a process of elimination. So this one out of it. Let's eliminate this, because this is a 4. This is a negative 2. So is that all right? And then the second value is 3 times this 3, which is 9. But this is a 9, and this is a 9 as well. So it is the third value that will tell us the answer. We have to work out everything. 3 times this negative 3 is negative 9. So the negative 9 here. So this one is eliminated. This value is wrong. This one is wrong. And that has a negative 6. So since these 3 values are correct, and we have eliminated answers on these 3, we don't have to go any further. This is the answer. You have to work out everything. Everybody go to that? Good. Nice and easy. Down here, it gives us this matrix, and it's asking us what is the inverse of A. In other words, what is A to the minus 1? Remember, A to the minus 1 is 1 over the determinant multiplied by the adjoint. A to the minus 1 equals 1 over the determinant of A times the adjoint of A. How do we do the determinant? 1 over, the determinant is this product, first diagonal product, minus this product. So the first diagonal product is 2 times 4, which is 8, minus the second diagonal product is 7 times 1, is 7. Times, so you know right away these 2 answers are eliminated, right? Because this under here says a 1. So this is eliminated, this is eliminated. The answer is one of these 2. We just need to get the adjoint now. How do we get the adjoint? We interchange the elements on the first diagonal. Interchange these 2 elements. Interchange them, the 2 and the 4. So you switch them around, so you're going to get 4 up here and 2 down here. So you see this has a 4 and the 2 here. Because this has negative 4, negative 2, so this one is also wrong. We don't have to go any further. The answer is this last one down here. We don't have to go any further. That is it. A lot of the time, they don't have to work out everything, you know. Use a process of elimination. Remember, the answer is on the paper. So as soon as you eliminate an answer, you mark it off. You don't have to work out everything fully. It's a multiple choice exam. Let's continue. Next one. This gives us these 2 matrices, P and Q, and the first question is asking us for the order of matrix Q. Remember, it is rows by columns you want for the order. That's what the order is. The rows by the columns. This has 3 rows, see? 3 rows. And it has 4 columns. So it has 3 rows. Let me mark them out. 3 rows. And it has 4 columns down here. 4 columns. So it's a 3 by 4. 3 by 4 matrix. Rows by column. This is the answer. Let's get these right. This question says, the determinant of P, that is this matrix up here now. This question refers to this question 27 and 28. And so on the determinant of this matrix now. So the determinant of P, which is written like that, becomes equal to this product, that is the 8 times 5, minus this product, which is the 7 times 6. So the 8 times 5 is 40. The 7 times 6 is 42. 40 minus 42 is negative 2. So the determinant is this negative 2 right here. What go with that? Okay, beautiful. This question gives us these two. That's a matrices equation. Equality of matrices. You want us to find the value of x and y. So we can make the two matrices become equal. What it is that this 5 times this x is going to be equal to this 4 times this 10. But can I get that? So we're going to get 5x equals 40. Agreed? 5 times x equals 4 times 10. So we're going to get x equals 8 if you divide by the 40. This is the only answer with x equals 8 in it. So this must be the answer. And the question like this now, when you finish the exam, if you never do the second part, when you finish the exam, you're coming back, you just check to see if the y is correct as well. Just check. All right? On the second go around. And in that case, the 5 times y will be equal to 4 times 20. 4 times 20 is 80. And 80 divided by 5 is 16. See, 80 divided by 5 is that 16. So you know, say it right. So the y will be equal to 16 as well. But you did not have to work this out. This part is not necessary. Could have gotten the answer from right there. But I would check this. If I finish the exam, I'm going to come back, I'm going to double check my answers, but just check this as well. All right? All right, beautiful. Let's continue. Oh, so you see, matrices done. You're not going to get a lot of matrices questions on the paper. All right? Matrices done. And when they set them, you don't get a lot of repeats. Or you don't get a lot of variations in the questions. So let's go down to vectors now. Not a lot of vectors either. All right, not a lot of vectors. All right. So this one says, these are two matrices P and Q. And they're asking us for minus P minus 2Q. Now, you see this thing? They set this different here. Look over here, so. Same two matrices, same two vectors, sorry. And now they're asking us for P minus 2Q. See it? This one is minus P minus 2Q, and I know it's P minus 2Q. Look down, I say another one again. See, this one is just now P minus Q. See that? P minus Q. Look at this one. This one is P minus 2Q. So you see, they keep asking basically the same thing, just making that minor change. Don't give it away. Do not give it away. Be careful. So this one you want minus P minus 2Q. Let's set it up. So it becomes minus the P. This is the P. Minus 2 times Q. This is the Q. Take your time and work it out. This one becomes negative 3, negative 2 when you apply the minus on it. Minus, I'm going to multiply with the 2 now. So multiply the 2 by these values, I'm going to get minus 2 and 8. All I did was multiply by the 2 alone. I'm leaving the minus for last. Then you're going to get negative 3 minus a negative 2. Let me show you what that becomes. Let me shift this over some. Oh, sorry. Let me shift this over somewhat, a bit. Smaller and shift it over a little bit. This one is going to become negative 3. This minus becomes a plus. So it will become negative 3 plus 2. And it's become negative 3. So the answer is negative 1. This works out to be negative 1 now. That top value is -1, and so we're done already. This is the only answer with a -1 on it. So that's my answer. Because this is -1. See it? -1 is the top value. But if you check the second value, you're going to get -2 and -8. -2 and -8, that becomes -10. So you see, that is indeed the answer right there. Nice and easy. We get the same two matrices again. No, not two different matrices. It's 3, 7, but this is different. But this time I'm asking us for P minus Q, kind of easier. P minus Q. So basically just doing the 3, 7 minus the -2, 5. That's what we're doing. P minus Q. The 3 minus a -2 becomes 3 plus 2. And the 7 minus 5 is 7 minus 5. So this works out to be 5, 2. This is 5 and this is 2. 5, 2 is the answer. 5, 2. Where's my 5, 2? This is 5, 2. Come on, let's not give these questions away. They're too easy. Let's work this one in the box. This now wants P minus 2Q. Same two matrices in here. But it now wants P minus 2Q. So let's set it up this way. We're going to do the P, which is the same 3, 7, minus 2 times this. So doubling the values. So we double this -2, we got -4. Double this 5, we get 10. Remember now that this minus becomes a plus. So this becomes 3 plus 4. And 7 minus 10. 7 minus 10 in that single matrix. This is a 7. This is the only answer with a 7. This becomes 7 and this becomes -3. So the answer is this one. 7 minus 3. Take your time and don't give it away. Make sure you get the right answer. This one over here, give us the same two matrices, but now the one P minus 2Q. Same thing again. Put on the P first. That's 3, 2 minus 2 times this one. So you're going to double this one. So that just double this -1, you get -2. Double this 4, you get 8. That's what you're working out. This minus a plus again. So you really get 3 plus 2. And this is 2 minus 8. 2 minus 8. This is a 5. The only, well, they have two answers with a 5 now, so you have to check the second value. So this works out to 5. This 2 minus 8 is -6. So it's 5, -6. This is the answer. Nice and easy. Very good so far. Beautiful. Let's continue. Here now, see this question? I'm going to tell you what this question is testing. This question, this is a parallelogram, right? See the diagram of a parallelogram. It's testing your knowledge that these two opposite sides are equal vectors. And these two opposite sides are equal vectors. In other words, this vector, if this vector over here so is WX, then this vector, even though it is ZY, it is also WX. WX. So you can say ZY equals WX. As these two sides are equal vectors, and you can say WZ is XY. WZ is XY, right? WZ is XY. So you can say WZ is XY. That's the information you get from the parallelogram. Question says, what is ZR? Look at the diagram and how do we go from Z to R? R is the midpoint. It told us up here that R is the midpoint of this side. All right? So R is the midpoint. So how do we go from Z to R? Let's set it up. We go from Z to R. We're going to come up here so first and go Z to Y. And then we're going to go half of YX, sorry. Because the zy is half of the y. Let me say it again. The yr, sorry, is half of the yx. Let me write it out. So we're going to come up here so first. To go from here to here, we're going to come up here so first. So we're going to go from z to y, and then we're going to go from y to r. But the yr is half of yx. So this is zy plus half of yx. All right, half of yx. Let's look at it now. That's what it is equal to. We try to see which one of these answers. But if you notice, these answers are expressed in terms of wx and wz. So that's why we have to be careful now. All right. So the zy is the same as wx. So we can put this as wx right here. They want half of yx, sorry, half of yx. But the yx, well, all right, so this is yx. So what does that mean is that we're going to have to introduce a negative. Because we're going in the opposite direction. Because these answers expressed in terms of wz. What we have to recognize is that if this is wz this way, then this is also wz this way. This way. But if we're going this way, then we're really going minus wz. So from here to here, tell me if you can see, from here to here becomes minus half of wz. But you can see that? Because the whole thing across here is minus wz. So this then from y to r is minus wz. So you see this y to r here, so we'll change it. This y to r. I'm going to change it to minus wz. All right, so this becomes minus wz. So this plus minus becomes minus wz. This is minus half of wz, I should say. Minus half of wz. Come on, Mr. Shaw. Minus half of wz. That's what the y to r is, minus half of wz. So this becomes minus half of wz. Much time on this question, minus half of wz. So looking for that answer, wx minus half of wz. Oh, wx, that is not there. Oh, see it here, right here, wx minus half of wz, yes, that is it. All right, so this question, two things it tests your knowledge of. And the opposite vectors are equal, opposite sides are equal vectors. And then if you go in the opposite direction, you introduce a negative, right? The negative in vectors means opposite direction, all right? That's what this question is testing. All right, let's continue down here. So this question now gives us this vector diagram again. It's a parallelogram again. So you know the opposite sides are equal vectors. It says xy is u. That's right up here. Is u. Let me get ready. And it says xw is v. Xw is v. So notice that xw is going down. V is going down, right? And this one is going this way. So if you look at the vector here, question is asking us for WR. WR. So in other words, we're going from W to R. All right, let's populate the diagram. Kind of easy. So since this vector up here so is u, then this vector down here is also u going across here. This, all of this is u, just like up here. And since this vector coming down here so is v, then coming down here so is also v. The whole of this is also v down. But this r divides it half and half. So this vector becomes half of v down. And from here is also half of v down. So you can look at it now. Quite simple. To go from W to R, we're going to come out here so with a u first. And then we're going to go a minus half of v. Why is it minus? Because we're going in the opposite direction to that half v. All right? So that works out to u minus half v. To go from here to here, it is this u minus half v because we're going in the opposite direction. So that is the answer. U minus half v. WR becomes this u over to here, and then minus half v because we're going to go opposite direction to half v. Minus half v. That's what we're looking for. U minus is the first one. U minus half v is the answer. That's WR. Don't use a similar question. Diagram refers following diagram. It's a parallelogram again. EF is parallel to HG. EH is parallel to FE. So these opposite sides are parallel again. Let's get the red. All right. It says EF is K, that's this one. And EH is M, that's this one. So automatically, since this side is K going this way, then this side is also K going that way. So this vector is also K. And since this vector coming down is M, then this vector coming down is also M. So coming down here is also vector M. That's what we know. The opposite sides are equal vectors. Question wants us to get EG. E to G, easy. That's K plus M, you know. E to G. How we know is K plus M? Come across here to F first with the K, and then come down here so with the M to G. That is it. All right, to go from E to G, come across here so first, and then come down here so with the M. So it becomes K plus M. See here? K plus M. But go to that. You okay? Make sure you're not birthday girl. You have a shut up exam Friday. Exam just dead. Friday. Birthday gift to yourself. Next question. Item 30 refers to the following diagram. Triangle PQR. L is the midpoint of this side. L is the midpoint of this side, right? And it says QP is this vector A. Notice it is going this way. And QR is going this way. Opposite direction, going that way. And L is the midpoint of this side. All right, what do they want us to find? They want us to find PL from P to L. So PL is just half of PR. Everybody can say that? PL is half of PR. All right, so let's set it up now. PL is half of PR. So how do we go from P to R now? Can come across here so first, minus A, and then go up here so with a B, don't it? But can I say that? To get the PR. Agreed? Good. So it's gonna become half of, and we'll put in the PR now. The PR is, as I said, minus A, because going in the opposite direction to A. Minus A, and then plus B, because going in the same direction as B. Plus B. So this is the answer. Looking for that answer now. All right. So it's minus A plus B over 2, basically. See it here? Minus A plus B. They just switch it around. They just switch it around. They put it as half bracket B minus A, and then put the 2 under here. Don't matter. They put B minus A over 2 is the same thing. So this is the answer right here. Bang. That is it. B minus A over 2. Nice and easy. Take your time. Remember, vectors is about how you go from point to point, going along the vector direction that you know at this level. That is all you need to do. Go around the point, go around from point to point, going along the vector direction that you know. That is look clear? I don't want to sharpen up a little bit. It's okay? All right. All right, let's continue. Online, everybody good? Everybody good online so far? Alexander, you okay? Until you okay? Nobody online sleeping. All right.
Yes, sir.
Okay.
Good. Let's continue. Another vectors question right here. It says, item 30 refers to the following diagram. Triangle OLM. R is the midpoint of OL over here, so R is the midpoint. It says, further, OR is this vector. So O to R is this vector. It simply means that O to L is 2 times this, guys. Not complicated. Look at it. If L is the if R is the midpoint of OL, R is the midpoint of OL, and from O to R is this. O to R is this. Let's put on the diagram. 3A minus 2B. Then this is the same vector because it's the same length, same direction. So this is the same vector. 3A minus 2B as well. So from O to L is the sum of this and this, which becomes 6A minus 4B. They're asking us for LM. What else did they tell us? OM, they gave us OM down here. OM down here is 2A plus 3B. And now they're asking us for LM. LM, to go from L to M. So to go from L to M, we can use O time last minus O time the first one, but we can go from L to O first. Let me use it ready. To go from L to M, we can go from L to M, we can come down here so first, and then go across here so. Come down here this way and then go that way. To go from L to M. So if you come down here, so we're doing 2 of this. We're doing this and this. See, I'm going in the opposite direction. Note I'm going in the opposite direction. Easy. So go from L to M. We're going to go this way, which is minus 2 of these. So it's minus 3A and 3A is 6A. Minus 2B and minus 2B is minus 4B. That's to come down here, so you know. And then we're adding this one. So we're going this way now, using this vector. So adding that vector, which is now 2A plus 3B. 2A plus 3B. So we're talking. We're talking, get me running out, you know. 2A plus 3B. So you're adding 2A plus 3B. But understand that? But that's how I put the minus here, so I'm going in the opposite direction to these. And why did I double this value? Hold on a second. Why did I double these? Because it's 3A and 3A give me this 6A. And minus 2B and minus 2 give me the minus 4B. And the minus in front is because we're going in the opposite direction. Let's see to work this out now. Careful. Can expand this with a negative first. Minus 6A. Minus 6A. Minus minus give me plus 4B. Plus 4B. This is still 2A plus 3B. Consolidate the values now. Minus 6A plus 2A is minus 4A. Minus 4A. 4B and 3B is 7B plus 7B. That's the answer we're looking for. 7B minus 4A. See it yourself? Circle it in red. 7A and minus 7B and minus 4A. 7B minus 4A. This is it. 7B minus 4A. That's his answer. But okay with that? All right. Let's get these questions right on Friday. Come on. If we change the values, we need to know how to work them out. This question says, item 30 refers to the following diagram, which is triangle OLM, in which R is the midpoint again of OL. And this time, they tell us that this vector is A, T is the midpoint, T is the midpoint of OM and OT is B. OT is B. So right here says B. So if right here says A and R is the midpoint, it means that right here says also A. Let's put on the vector directions. OR is this way. That's the vector A. And so RL is the same vector A again. So the whole thing up here says a 2A. A and A. Similarly, this vector from here to here is B. This is the midpoint. It means that this length is the same and the same parallel as that. So this vector out here is also B. So the whole thing out here so is B plus B, which is 2B. Let's see what they want us to find now. They want us to find RM, R to M. Let's mark that out in blue. Or we'll go from R to M. To go from R to M, we're going to come down here so to O first, which is a minus A. And then we're going to go all the way out here so to M, which is that 2B, B plus B. So that one is clearly minus A, because you're going in the opposite direction to A, and then 2B, B plus B. See there? Minus A plus 2B, which is the first one, same as 2B minus A. This is it, same as 2B minus A. Minus A plus 2B, same as 2B minus A. But go with that. Good, nice and easy. Next one is the same diagram. So this, they gave us this same diagram on another exam paper, and this one they asked for LM. LM, to go from L to M. So that one kind of easy. Let's do the purple for that. To go from L to M. So we're going to come all the way down to O again using minus 2A, and then go all the way across here, 2B. So it's minus 2A this time, plus 2B. See here? Minus 2A. That take it down to O using the diagram. Minus 2A, take it down to O, and then go from O to B, O to M with the 2B. Plus 2B. Minus 2A plus 2B. But they factorize it. See? They factorize it now. So they turn it around and then they factorize it. Because this is the same as 2B minus 2A. That's the first thing. And then the factorize the 2, you get B minus A in the bracket. So factorize the 2. So the answer is this one. All right, but good? All right, beautiful. And that finishes vectors. See, well, most of those questions about how you go around the diagram. Be careful, don't give it away. All right, we're going to jump down to functions now, guys. We're going to jump down to functions. We did all of these already yesterday. So we did statistics again yesterday. So we're going down to functions, relations, and graphs. Here you go. Functions, relations, and graphs. Hey, the class going on here? Class going on. Functions, relations, and graphs. So ready, let's go. So after we do the function, relations, and graph, we take a break. And I want to come back and do the last topic. So we should finish earlier today. But remember, tomorrow now, we're doing 6 papers tomorrow. And 6 papers Thursday. All right, ready? This question says, given that y varies directly as x, and y equals 19 when x equals 152, which of the following equation represent the relationship between x and y? So firstly, y varies directly as x. If it's a direct variation, it means that the first variable y is equal to a constant times x because of the direct variation. Means k times. And I wanted to find the k. That's what the equation is. This is what this is about, you know. Using these values to find the k. That's what this question is about. So you can write about the equation with the k in it. So how you do get the k? You divide by the x. So from this, the k will be equal to y over x. And you're putting in these known values here now to find the k, because the k is a constant. Put in your known values. And then after I get your k, you put it back in the equation right here. So the y is 19. So the k equals 19 over the x is 152. 152. What a number nasty, man. Because that's a prime number. Which one of these is the answer? 8. The wicked man. What the wicked so? 152 divided by 19. That's 8. So this works out to 1 over 8, right? So the k equals 1 over 8. So from this, the k equals 1 over 8. 1 over 8. So you take the 1 over 8 because 19 to this was 1 time and 19 that was 8 times. That's what I did, guys. Right? So 19 goes into this 1 time and 19 goes into that 8 times. So that's why I get the k equals 1 over 8. So now that we know that k is 1 over 8, we're going to take it and put it back in the equation right there. So for the k. And so the equation becomes, let's write it, the equation then becomes y equals 1 over 8x. Y equals 1 over 8x, this one. Now remember, if you change this word to inversely, if you change this word and say inversely instead of directly, say inversely, then you'd have to write y equals k over x. K over. If it's an inverse variation, it's k over. And then you'd have to multiply the x up here. And so k equals x times y. And that's how you'd have to find your k by multiplying the x times the y. That's if they said inversely. This is what you'd have to do if it was inversely. But I can give out the same question with the same values and put inversely instead of now. And you'd have to multiply the 19 and the 152. All right, so look out for that. Next question. The distance L of an elastic string is stretched. Let's go again. The distance L that an elastic string is stretched by hanging an object of mass M varies directly as the mass of that object. And the mass is M. Boy, I'm complicated, man. So the distance L is direct proportional to the mass M. That's what the basically is saying. All right, let's go again. The distance L that an elastic string is stretched by hanging an object of mass M varies directly. So the length L varies directly as the mass M. That simply means that L is equal to K times M. That's what that means. L is equal to a constant times M. Watch this now. It says if a 5 kilogram object, this is the M now, stretches the string 31 centimeters, that's a L. So this question giving you this as your M. This is the M. So that's a M equals 5 when the L equals 31. Stop talking. How far will 29 kilogram stretch the object? I don't like, they put too much wording in this question. How far will it stretch the object? So let me show you can approach this question now. Because this question, you don't need to find the K, you know. You don't need to find the K, right? So watch this now. So what this means, because of this relationship, it means that from this, it means that the K is equal to L over M. Because I divide by the M. What can I say that? What can I say that? This is the relationship from the statement. But this then now means that the K is equal to L over M. I'll just take the M and divide it under the L. So the K will be equal to L over M. It means that the L over the M is always a constant. The length divided by the mass is always a constant. Get me? Good. So the L over M is a constant. Watch this now. So the L over the M is a constant, guys. The L over the M is a constant. So the constant will be equal to this L over this M. 31 over 5. It's also going to be equal to the other length that you're trying to find. It says, how far will that 29 kilogram object stretch this string? That other L, look on that other length, we're going to call it L over 29. This is what you're solving. You're solving this for L. You're working out this part now for the L. Because the L over the mass is a constant. So L over the mass for this pair that they gave you equal L over the mass for the pair that you're trying to find. And that's why you can work out the L. I don't even like these values that they give. They're so unreasonable with these numbers. Why they give these numbers in a multiple choice exam? And you can't use a calculator. It's unreasonable. But anyway, enough work it out. So to find the L, you have to multiply the 31 up here, so the 29, I mean. So the L that you want over here is going to be equal to multiply the 29 up here. It's going to be 31 times 29 over 5. That's what you're working out. If you can't sit down and work it out, look like a big number. I'm using my calculator. 31 times 29 divided by 5. And that becomes 179. It becomes this. It's a pity that you have to work out this calculation. You just have to work it out. You have to work it out. I can maybe estimate, right? Because I see this times this is almost 30 times 30, you know. It's about 900, right? And they divide the 900 by 5. And 900 divided by 5. If I'm in the exam, I might do this in the exam to estimate it quickly. Because this is 31 and this is 29. I'm going to say, okay, it's approximately 30 times 30 over 5, which will become approximately, divide this into this, I get 6. 6 times 30 is 180. So the value close to 180, which is this one. Let me leave this calculation on the paper as a way of working it out. So I'm going to work this out and say L is approximately 30 times 30 over 5. And then 5 into this 1 time, 5 into this. So 6 times 3 is 8. So it's approximately 180. So approximately 180. So the closest value to 180 is this one. All right. And that's what I would maybe do in an exam with those unfriendly numbers. Those are some unfriendly numbers to work with. All right. So little things like that you have to maybe do in an exam. But you can't use a calculator. So I think it's unreasonable to give values like those. I can't give easier values to work with. Let's look at this one down here. Given that y varies now inversely, see there now another question. So this one now, let's change the color. Y varies now inversely as x. That means that y is equal to k over x. Y varies inversely as x. And y is 17 when x is a half. Which of the following equation represents the relationship between x and y? So this is now they wanted to find the k. So I'm going to multiply the x here to find the k. The k is going to be equal to x times y. The k is going to be equal to x times y. This x and this y, you multiply them. So the k is going to be equal to half of 16. So the k is going to be equal to 8. It's a better question. I don't want to give you all these weird numbers, 31 and 29 and so. In an exam that you can't use a calculator. Unreasonable. But trying to move fast. So that I will know that the k is 8. You're going to drop it back up on the equation here. So drop it back up on the equation right here. And then we're going to get that the y equals 8 over x. Because the k equals 8. 8 over x. See here? Y equals 8 over x. Better go to that. Online. Better good. So this was the inverse one, right? All right, good. This one says the point where a linear function crosses the horizontal axis is the horizontal axis. Horizontal axis is the x-axis. So, and so that is the x-axis intercepted. Look at this one now. The point where a linear function crosses now the vertical axis, see? And a different paper, they just change the word from horizontal to vertical. Same thing. And see, they gave the same answer, the same 5 answers. That's why you have to read carefully. This one said horizontal, this one said vertical. The vertical axis, we all know, is the y-axis. And so this one is talking about the y-axis intercept. Y-intercept. 2 different questions, 2 different years, they just change 1 word. So don't go assuming the questions are the same. Read them carefully. Don't depend on swatting answers. And I can make 1 simple change like that. Next one. The equation of a line which passes through this point, another gradient of 4. So we have to recognize that since it passes through 0, 5, this is the y-axis intercept. Means that the c is equal to 5. And this is the gradient. This is the gradient, the m. Equation is y equals mx plus c. When you know the m and the c, you use this equation. So it's y equals 4x plus 5. But I said that. See it? Point is 0, 5. So it's a y-axis intercept. They might change this question and put 5, 0 in, guys. They put 5, 0. The c not equal 5 anymore. You can't use that method y equals mx plus c anymore. You get me? If you change the point to 5, 0, this is not the y-axis intercept. If you change the point to 5, 0, let me show you what you have to do. If they give this point as 5, 0, if they give the point of 5, 0, so let me write it down here. If the gradient is still 4, but the point is 5, 0, then you have to gonna use y minus the y value at the point equals the gradient into x minus the x value at the point to get the equation. You get me? They would use y minus the y value at the point is 0. The gradient is still 4 into x minus the x value at the point here is now 5. Come on, man. 5. If they change around the coordinates on the point. And so you get y equals 4x minus 20. That would be the answer. Y equals 4x minus 20. If they simply reverse the coordinates on that point to change the question on. You get me? Look out for stuff like that. All right. So the answer for this one is 4x plus 5 right here. Don't give it away, please. Don't give it away. You need to get 60 out of 60 on the exam. You need it. Need it. You need 60 out of 60. No less than 58. Don't make any sense. We expose all these questions and get less than 58. Don't make any sense. All right? Don't make any sense. Let people who are not exposed to these questions get less than 58. Come on. You want this paper? All right, I sent it in the group when I'm done. But I sent one already in the group, you know. I sent one in the group with all the answers. Yes. I sent it in the group. Resend it. It's in the group. I sent it in the group. Send it in the group. Check the group. This one says, the line L, all right, I sent this one. Because this one has some different questions on it. So I'll send this one again in the group. All right? Good. This one says, the line L is parallel to this. A line L is parallel to this. They say, what is the gradient of the line L? If they're parallel, they have the same gradient, don't it? We just need to work out the gradient of this line. To get a gradient, you have to put it in the form y equals mx plus c. Careful. Y equals mx plus c we want. We're looking for this value. Note though that it is y alone must be the subject. We have a negative 7y right here, so we have to be careful. because of that negative 7y. What I would do, I would take the negative 7y and transpose over this side by itself first and make it become a positive 7y. So I would do this with the equation. I would do this. I would say 3x minus 9 equals 7y. 7y. Then I would divide 2 by that 7. I'm going to divide 2 by the 7. Let me put it. Divide 2 by 7. Divide 2 by 7. Now divide 2 by 7. I'm going to get 3 over 7x minus 9 over 7 equals y. It's the same equation like that, you know. You just have to spin it around. I can spin this around if I want and put it as y equals, not 3 over 4, Mr. Short, 3 over 7. Spin it around and put 3 over 7x minus 9 over 7. This is the gradient right here you're looking for. This is your m. So you're looking for that gradient since they are parallel. They have the same gradient. See it here? Parallel, same gradient. Well, you have to find a gradient out of this line by making y the subject, y alone. Careful with this negative sign, guys. Careful. All right. So the gradient becomes 3 over 4. You're looking for 3 over 7. Sorry. See it here? 3 over 7. Now you could have just changed this word and put perpendicular. Then you would want the negative reciprocal of this gradient. Let me see if there's any with that. Let me see. This one's a parallel again. Ah, so one here is a perpendicular. Good? Good. One's a perpendicular there. So let's do this parallel one again. See? They put a negative 5. The same question, they just change the values. But use the same approach. Let's use the same approach. We're going to transpose this and bring over the 5y and get 2x minus 8 equals 5y. We don't want this 5. We'll divide 2 by the 5. Divide 2 by the 5. When you divide 2 by the 5, you divide each term by 5. Okay, you want to see the mx in it. You want to see the mx. So you divide this by the 5, you're going to put 2 over 5x minus this becomes negative 8 over 5. That now is equal to the y. Again, this can be spun around and the y can be placed over on this side. Same thing. Y equals 2 over 5x minus 8 over 5. This guy is your gradient. And because them say parallel, parallel means same gradient. Same gradient. Parallel lines have the same gradient. I-E-N-T. Don't give it away. So you're looking for a gradient of 2 over 5 right there. So the answer is this one because they are parallel. There's a perpendicular example here, so now see there. Same kind of question. But this time, then give it a gradient. The same equation. Look. Almost the same. You have 8 over 5. Almost the same. Almost. This one says a line L has this equation. A line L is perpendicular to a line with this equation. What is the gradient of line L? Perpendicular lines have negative reciprocal gradients. See here, then perpendicular. So they have negative reciprocal gradients. When lines are perpendicular, gradients have negative reciprocal, meaning you flip the one that you have and change the sign. So the gradient of this line right now is 2/5. So like you're basically saying this. The gradient of the second line is going to be equal to -1 over the gradient of the first line. This is the gradient of the first line right here, M1. This is the M1. And you're trying to find M2. Flip this and change the sign. This calculation can be done by flip and change the sign. Let me write it out for you. Flip and change the sign to do this calculation. Flip. and change the sign. Which sign we're talking about? The positive or negative. If two lines perpendicular, one gradient will be positive and the other one will be negative. Them can't have the same sign if them perpendicular. So if one of them gradient positive, the other one have a negative, and it's also the reciprocal. So this calculation that we're trying to do, we just flip the 2/5 and change the sign. So we don't have to actually work it out. Just flip the one that we have and change the sign. So it becomes -5/2. That's the gradient of the perpendicular line, the gradient of L. Let's put L here, so instead of L2. L, the gradient of L, the second line, the perpendicular line, is -5/2. This is it. Everybody understand that online? Everybody understand that? You good?
Yes.
All right. Come here, forget them questions I write in an exam tomorrow, Friday. This equation they give us on this question is another question, you know. They give us y equals 3/7x. I think this is a -9. And the same question, same wording, but they give us this equation instead of this one. So in this case, the gradient is this 3/7. And it's perpendicular again. So this is the gradient of line 1, M1. And you want the second gradient, M2. Let me write out in blue again. But this one, the M2 is -1/M1. That is done again by flipping this 3/7 and changing the sign. So the gradient of M2, the second gradient, the perpendicular gradient, is going to be -7/3. You flip the 3/7 and change the sign. Looking for -7/3. Let me make that this for you. This is -7/3. This is 9/7 negative. This is 3/7. And this is 7/3. But this question related to perpendicular again. So looking for this perpendicular gradient of this one. Flip the one that you have, change the sign. So in this case, the answer is A. Don't give it away. Too easy. Let's continue. One more question here, so. So this one says, what is the gradient of this straight line? A lot of people going to put -3 now. Wrong. You have to get y alone as a subject, guys. You need to get the equation in the form y alone equals mx plus c. Y alone, not 2y. We need to get rid of this 2. So we have to divide 2 by 2. See that? So let's do it up here. Here, we're going to divide through by 2. Divide through by the 2. Or you can say multiply through by 1/2. Same thing. When you divide through by 2, the equation becomes y equals, you divide this by 2, we get -3/2x. Divide this by 2, you get -4. If they ask for the y-axis intercept, it is this, you know, the -4. It will be 0, -4 to ask for the coordinates of the y-axis intercept. But all these questions are asking for gradient. I don't see a lot of them asking for y-axis intercept. So the gradient now, because it's the gradient, because this becomes the gradient now, this thing, -3/2, the m. So we're looking for -3/2 right here. This question, -3/2. See it here, so -3/2. This is another same question. Oh, see it here now. Same thing, you know, but ask for the y-intercept now. All right. So I talk about the same equation, you know. See there? But this time they ask for the y-intercept. See that? On a different exam paper. Same equation. This one asks for gradient. This one asks for y-intercept. So we're looking for the c value now. So again, we write this in the form by dividing by 2. Divide by 2 again. Divide by 2. Because we're trying to get y equals mx plus c. We're trying to get y alone to be the subject so we can see what the c is. When we divide 2 by 2, this equation is going to become y equals minus 3 over 2x. Divide this by 2, you get negative 4. This is your c value. Your y-axis intercept. Let me circle it in red for you. This is your c. And don't forget the sign, you know, guys. That is your c. Don't forget the negative on it. It's not 4 is the answer, it's negative 4 down here. So see it here, so bang. Negative 4. All right. Some question I might put a 4 to beat you up. But you see what they do? They put the gradient as a part of the answer to, you know. So if you don't read carefully, you might go mark gradient, you know, thinking it's the same question. But this time they ask for y-axis intercept. So be careful. All right. All right. All right. Let's continue. So a question here now. This question says item 47 refer to the following graph of a straight line. Straight line AB cuts the y-axis. The y-axis is this point right here. At that point, the x value is 0 and the y value is negative 2. 0, negative 2 right here. See there? I see another question. I'm going to get the same graph and ask for it to cut the x-axis. Let me see if it is here. No, it's not here, but I've seen it. So instead of y-axis, if the question had said x-axis, the question said x-axis. Instead of y-axis, that would be 3, 0. That would be right here. They had asked for the intercept with the x-axis instead of y-axis to be 3, 0. I don't have it on this document, but I've seen it with the ask for x-axis instead of y-axis. All right, over here now. This question says they give us this line AB, and they say what is the gradient. To get the gradient of this line, we just need to count the rise and count the run. Count the rise and count the run. You have to make sure that the grid, you have to count the scale on the grid. Every box is 1 unit going up. See that? Every box is 1 unit. You can see that, right? Vertically. And every box is 1 unit horizontally as well. So to go from here to here, we just need to count the rise and count the run. You have to calculate nothing. And always go from left to right. Always through the point going from left to right. So from A to B, we're going to rise 2 units. See that? You're rising 2 units. That's the rise. And then you're going to run how many units that? 1, 2, 3, 4. Run 4 units this way. Positive, everything positive. Run 4 units. So gradient is rise over run. Gradient is the rise of 2 over the run of 4. 2 over 4 is a half. Right here. 2 over 4 is a half. Let me show you something now. Remember, just to show you something. If the line that I gave you was sloping down like this, for example, and the A was here and the B was there, it was like that. That's going to have a negative gradient. Because, remember, always go from left to right. Because, in this case, you have to come down. That will be a negative rise. And then you have to run, positive run. So the rise would be, for example, let's say this is 1, 2, 3, 4, 5. Rise negative 5. And let's say this is about 1, 2, 3, 4 run. Run 4. Let's change the letters to P and Q. I'm just making up one if they give you a negative gradient, what you do. Let's say this is P and Q. So over here now, the gradient over here would be rise, no, negative 5 over run a positive 4. Okay, going to the right. So you're running 4. So when you have to rise down, the rise is negative. So this gradient would work out to be negative 5 over 4. if they give you a line sloping down like that. But I go to that. We don't know what's coming in the exam. You can get the same AB and make it slope down this way, right? And another exam paper. Really, it will be negative. You have to prepare for everything. Once it comes to mind, it can come on the exam paper. Let's continue. Which of the following lines are perpendicular? Perpendicular lines have negative reciprocal gradient. What you're looking for here, though, is when the lines are perpendicular, also remember that the gradient of one times the gradient of the second one equal -1 when they are perpendicular. This is something that is also good to remember. When the lines are perpendicular, the product of the gradient is -1. If the lines were parallel, then they would have the same gradient. So you're going to have to investigate these gradients until you find one where the product is -1. That's what you have to do. All right? All right, let's write out the gradients then now and look for which two the product is -1. If you can look at it and see that one is the negative reciprocal of the other, then that will work as well. All right, what's the gradient of this line here, so? Sorry. What's the gradient of this line right here, so? We divide by this 2, don't it? If you divide by this 2, we're going to get -3/2. So for this line, the gradient is -3/2. And for this line, what's the gradient? The gradient is 3/2. I want to know, because I will take this 2y and transpose. Let me write it out here for you. It will become 3x and q over the 8. I will get +8 equals 2y first. And then I have to divide by the 2 here. Right? And so the gradient of this second line would just be 3/2. If I multiply those two, I'm not getting -1. So those are not parallel, those are not perpendicular lines. They're not even parallel either. One gradient positive and one gradient negative. Same value, but one positive and one negative. So these two are not perpendicular. What about this one? These two parallel, don't it? The gradient of this one is 2, and the gradient of this one is also 2. So these two parallel. So if the question asks for parallel, this is going to be the answer. These two parallel. The gradient is the same. We're not looking for parallel, looking for perpendicular. What about this one? This look like it, you know. This look like it, you know. This gradient is -4 because I see already a y alone as the subject. -4. And this gradient, I have to divide by the 4 to get the gradient. Is it? You have to divide by this 4. So when you divide by this 4, this equation will become y equals 1/4x plus 1/4. You divide through by this 4. So this gradient is 1/4. If you multiply these two values, I'm getting -1. I'll put this in blue now. Right? See here now, -4 times 1/4 equals -1. So it means that these are the two perpendicular lines. These two perpendicular. That is it. Perpendicular. Perpendicular. These two lines are perpendicular. Those are perpendicular. What about this? Let's test this one. This one, the gradient is going to be a half. If I take -2 and carry it over here, come positive and then divide by 2, the gradient of this one is a half. And gradient of this one, if I carry over the 3x first and then divide by the 5, is -3/5. The gradient of this one is -3/5. So they're not perpendicular and they're not parallel. All right, so we have found the answer, guys. We have found the answer. All right, the answer is C. The ones where the product of the gradient is -1. Everybody good at that? Online, everybody good?
Yes, sir.
All right.
Yes, sir.
If you're not good talking, if you're not good talk up, exam is Friday. I want 60 out of 60. I want 60 out of 60. I'm serious. 60 out of 60. You can't read 60. 58 is the lowest. Nothing less than 58. This one. Which are the following which is the following represent the equation of a straight line. Equation of a straight line is one that can be transposed in the form y equals mx plus c. Not x, mx plus c. Or it can be written as ax plus by equals c. You can read like that as well. Like ax plus by plus c equals 0. You can read like this, you're good to go. In other words, you have separate x and y values in it. Anyone that can read like that. You don't want any that has products or quotients of x and y. No power on the x, no power on the y, no quotient, no product of the x and the y. So the equation of a straight line right just is this one. This is not a line because of a product of x and y. This is not a line because that's a square. That also is a square. This is a quadratic. That's not a quadratic, you know, but it's not a line. It's a curve shape like so. Right? And this is a curve, that's a quadratic. All right. Sometimes easy things are hard to explain, you know. Trust me. This one says, which of the following represent the equation of a straight line again? Can't be this either, because if you plug the x, you're going to get xy equals 4. Right? The same equation they're given now, but they write them another way. See it? See that one here? That one here is this, you know, up here, so. The same equation they write, you know. Because them just try to forward this side, this time. Same equation they're given now. I tell the people at CSEC, lazy. Lazy, they can't even set a new question. And the equation is the same equation, no, almost. All they have done, this 3, they put on this side, but they put the positive. Same difference. This is the line, though. All right? That is the line. Okay. Next page. All right. So this is more functions, right? So we're doing functions and graphs. So continue down here. So far going down. Still have a bit of way to go before we get to this, and then we'll take a break. All right. Let's continue. Some functions now, guys. Some functions. This question says, they give us this mapping diagram, and they say the relation that best describes the mapping is what? Look at it. Many to one. 2 different values. That's many values mapping to just one value. You can see it. Mapping to one value. See? 2 different values mapping to one value. That is many over here mapping to just one over there. So it's obviously a many to one. Many to one. Don't give it away, guys. Don't give it away. These things too easy. Many to one. This one says, if h of x is this, what is h of minus 6? Just put the minus 6 here, so. So this one becomes equal to, let's put it here, 3 times minus 6 minus about the 2 over 5. This is minus 18 and minus 2 give me minus 20 over 5. That works out to negative 4. The answer is right here. But I'm good at that. Good. See another one here. Same thing, you know, same function. But this time I want h of 4. H of 4 this time. Same thing. Put the 4 in there. So this one is going to become 3 times 4 minus 2 divided by 5. This is 12 minus 2. 12 minus 2 is 10 over 5. 10 over 5 is 2. 2 is the answer right there. This 2 right there is the answer. Come on, let's get these right. Whatever value they set, get it right. Come on. It's another one here. They give us another function, but they want h of minus 6. G this time. Put the minus 6 in there for the g, for the x, sorry. So it's going to become equal to 7 times negative 6 minus 3 over 5. 7 6 is 42, don't it? That's negative 42 minus 3 over 5. Minus 42 and minus 3 give me minus 45 over 5. 45 over 5 is 9. So this is negative 9 -9. Don't give it away. Don't put 9, you know. -9. Don't give it away, please. All right? That is that. Next one says, item 51 refers to the following arrow diagram which shows the function f. All right? Which of the following best describes the function? Let's look at it. These values mapping onto these values. The first one, let's test the first one. When the x is 2 plus 3, we're getting 5 and mapping onto 5. Good. It works for one value. Let's try it with another value. Let's try it with this and this. X is 5 plus 3, we get 8. Good. So clearly, we're mapping onto 3 more. So 3 plus 5, 2 plus 3. Give me 5 plus 3. Plus 3, you keep adding 3, so it's x plus 3. So the y value is x plus 3. See there, this answer is the first one. Don't have to go any further. The y value is x plus 3. Y is x plus 3. Easy. This one says, given that, or what is f of minus 1? Sorry. If f is this. This can be done multiple ways. You can find the inverse first and then plug in 1. Let's look at a nice way. First, you have to recognize that this thing is the same as f of x equals 5 minus 2x. That's the first thing, right? We're trying to find f of minus 1. Let's look at this neat way to do it. Watch this now. Trying to find f to my. Now look here. One way you can do it, you can try values, you can try the answers and see which one works. But watch this now. I'm going to say, I'm trying to find f of minus 1. So I'm going to say let, we don't find an inverse function. Can find inverse function. Let's do it the way most people do it, yeah, man. I think most people will find inverse function and plug in the one, right? Agreed? Agreed? Most people do that, don't it? So we're going to find the inverse function by making the f becomes x equals 5 minus 2, and this x becomes f to the minus 1. When you make this is subject, you find the inverse function and plug the 1 in it. So to make this is subject, we're going to take all of this and bring it over here so first and get 2f to the minus 1 equals, take this x and bring it over here and get 5 minus x. So far so good. And then divide under this 2. So f to the minus 1 equals 5 minus x over 2. And then you want to find f to the minus 1 of 1. So plug in 1 now. So f to the minus 1 of 1, plug in the 1 now, becomes equal to, we're going to put the 1 right here. It becomes 5 minus 1 over 2, which becomes 4 over 2, which is 2. So that says this 2 right here. Want to see the other way I was thinking of doing it? Want to see the other way? Let me show you the other way I was thinking. You have to calculate the inverse same way now. So leave it there, so. I still have to calculate the inverse. Let me show you still. More maths equals better maths. Let me show you the other way. My brain was thinking of doing. More maths equals better maths every time. I'm going to show you the other way. Let me show you the way I was thinking about, right? The answer is 2. Let me show you the other way right here. I was saying this. You're going to let f to the minus 1 of 1 be equal to some value n. It means that 1 is equal to f of n. See that? 1 is equal to f of n. What is f of n? F of n is when you plug n into here. So you're going to get 1 equals 5 minus 2n. When you find n, you find the answer, you know. See that? I can literally see it. The n has to be 2 for 5 minus. Because 5 minus 4 is 1. But if you solve it for the n, the same thing. You can curve 2n and get 2n equals q over the 1. You get 5 minus 1, which is 4. And then divide by the 2. So I'm going to put the 4 8. So the n will become 4 over 2, which is 2. And when you find the n, you find the answer. See there, that is the same. So that's another way it could have been done. That's another way. I think most people do it this way though. Most people find the inverse and then plug in the 1. But it's a nice, cool way to do it still. More maths equals better maths. Let's continue down here. Which of the following diagram best describes, illustrates a function? All right, let's talk about this one a bit. We're going to use a process of elimination. What is causing each of them not to be a function? Remember, it is a domain that decides if a relation is a function or not. What must happen? In simple terms, each of the values in the domain must have a mapping. Each of the values in the domain must have one arrow alone coming off it. You can't have any element in the domain that is not mapping. If you, for example, in this one don't have an arrow coming off it. That causes it not to be a function. And this one has 2 arrows coming off it. The mapping twice. That's one to many. So those 2 elements in the domain cause this one not to be a function. That's what I call that one to fail as a function. Get me? In this second one, this causes it to fail as a function. Remember, you don't care what I'm over the codomain, It doesn't matter what happens over the codomain. Codomain doesn't decide if it's a function or not. It is the domain that decides if it's a function or not. So you don't care about what is happening over here. You don't care about what's happening over the codomain. All right? It don't matter how the mapping is received. It don't matter if there's any free element in the codomain. That don't matter. What determines if a function or not, it is the domain. So your focus is on the domain. And what you're looking for, you don't want any free element in the domain that is not mapping. And you don't want any element mapping more than one time. So let's go again. This element don't have any mapping coming off it, so that fails it as a function. This also fails it because it has 2 arrows coming off it. It mapping twice. That's one to many. One to many relation is not a function. And then on the second one, this fails it as a function because it has 2 mapping coming off it. That's one to many. One to many is not a function. So that one fails it as a function. Down here, all of them fail it as a function. This double mapping fails it as a function. This double mapping fails it as a function. This also fails it as a function because it has 3 arrows coming off it. It mapping 3 times. Each element in the domain must only map 1 time. So the 3 values here fails this one as a function. So the answer must be the last one. See? This one, good. 1 arrow coming off it. Only 1 arrow coming off this one. Good to go. Good. This one. This one again. Only 1 arrow coming off it. Good. This one. Only 1 arrow coming off it. Good. Each of them has 1 arrow alone coming off it. That's why this one is a function. Good, good, good. So this is a function. Hope I explain it for those who didn't know before. That's all you're looking for. You don't want any free element in the domain, and you don't want any element to be mapping more than 1 time. Each element in the domain must map, and when they map, they must only map 1 time alone. Anything apart from that, you don't have a function. Remember, you don't care what is happening over in the codomain. It don't matter what happens over in the codomain. Your focus is on the domain alone. Here, so the domain alone is what decides if you have a function or not. Very good. So I've circled the things that failed them. So let me write the word fail beside it. So this one fail. Fail as a function. Not a function. Not a function. Because of these. This one makes it not a function. Not a function. Not a function because of this. Not a function. And then this one again is not a function because of those. So whoever send this document, you should basically look and see why those are not functions. I've circled why they are not functions. All right, what caused them to fail as functions. Boom, bang. Next one, over here. This one says, the set of ordered pairs below represent a relation that is a function. This is a function right now, right? That's a function right now. Look, 2 is mapping to 7. -4 is mapping to 6. 10 is mapping to 4. If you were to do a mapping diagram, those are your mapping. These values will be in the domain over here. The 2, the -4, and the 10. And these values will be in the codomain, the 7, the 6, and the 4. And the mapping will be like this. That's a function. Good? All right. Let me spend some time on this one so we can understand. Question says now, which are the following points? Which of these points, when added to this set, I'm actually going to draw by the diagram for you and show you. Which of these points, when added to this set, would form a relation that is now not a function? So you see, when it's not a function, is when it becomes a one-to-many. When it becomes a one-to-many mapping. When you have one x value mapping to many y values. So you're looking for the pairs. You're looking for the pair that has the same x value. This is mapping to 8. So if you add this to it, you're going to have 2 mapping to 7, and you're going to also have 2 mapping to 8. You understand that? So this point will cause it not to be a function. I want to know if you all understand that. Remember, now, we don't want this. If we have this, we do have a function. If you have one-to-many, it is not a function. Not a function if the relation becomes a one-to-many. If the relation becomes a one-to-many, it is no longer a function. Not a function. So how does it become a one-to-many? If you have one x value mapping to 2 different y values, then it is a one-to-many and not a function. So you want to see which of these points already have an x value mapping already. Right? So this one has a 2 that is mapping to 8. But we already have a 2 mapping to 7. So we already have a 2 that is mapping to 7. If you bring in this point, then you're going to have the same 2 mapping to 8. And then it will become a one-to-many and it's no longer a function. But understand that? That is why at this point, if you add it to this setup here, it's going to now fail as a function. It's no longer a function. But understand that? Online, understand that?
Yes, sir.
Online, understand that? I'm trying to explain it, guys, because they don't necessarily going to give you about the same values. See another example here, so. The same question, but with different values. So again, you're looking for an x value that is already mapping. You don't want x value to be mapping to no new value. So look at this one, it says, which are the four? Same question now. Same question on a different exam paper, but they change the values. They change the values. Watch this now. This one gives us these pairs. Right? It's the same values that they use, but they say, look here, now this was a 2, they put a minus on this one. This was a -4, they put this as a +4 now, and so on, right? So they make a little bit of change. So watch it now again. It says, when added to the set, which are the following points, when added to the set, would result or would form a relation that again is not a function. It's the same thing you're looking for. Your focus should be on your domain values, these values. You don't want any of these values to be repeated, mapping onto another value. Remember, it is a domain that decides if it's a function or not. So your focus is on the domain. So looking for anyone that has the same domain value mapping. So see it here. See -2 years again. Bang. See that? You don't want that. You already have -2 mapping to 7. This point would now map the -2 to 8. And then it would not be a function anymore. So this is a point that will cause it. If you add this point to this setup here, so you will no longer have a function because you will have -2 mapping to 7 and you'll have -2 mapping to 8. So this is the point that will cause this relation or this point. If you add it to these points, if you add this point to these points, you no longer have a function. But good at that? All right, so them change the values in the exam. Make sure you get it right now. All right. Online, everybody good?
Yes, sir.
Online,
Yes,
everybody okay?
yes,
All
sir.
right.
Yes, sir.
Good, good. You don't want your domain values to be mapping to 2 different values. All right. So once the domain value is repeated, and is mapping to another value in the codomain, is no longer a function. All right. Enough of that. Next one. Which of the following point lies on this line? So basically, you want to know which of them when you plug in the x value and work it out to get the y value. That's what it is. So we can basically test them, right? That's what it is. So the y value, look at it. The y value is 2 times the x value minus 3. That's what it is now. So you're looking for that. The y value is 2 times the x value minus 3. Let's try the a first. This one. So the y value is 2 times. So we're testing this in here and see if we get 3. So it'll be 2 times 2 minus 3. That will be equal to 1. But this y value is 3. This is not equal to 3. So this one wrong, right? That's not on the point. Try this one now. Try the x in there. So that will be 2 times -2 minus 1. 2 times -2, that's -4, and minus 1, that's -5. This -5 right now that we're getting with this -2 is not -1. It's not -1. So it's not going to work as well. So try this point now. We're going to plug the 4 in there now. 2 times 4 minus 3. I know so this dance a long time, you know. Because that's a y-axis intercept. What a question, wicked. This is a y-axis intercept for this point, for this line. This is the y-axis intercept. An easy question, really, you know. Shall I look at the answers first? That's the obvious y-axis intercept, right? It's not need no calculation. But let's finish off this. This would fail as well. That's why sometimes good to look at all the answers in the book. This will become 8 minus 3 is 5. And 5 is not 1. Is not 1. So this also, these points are not on the line. They don't satisfy. The answer is this one. Y-axis intercept. Let's continue. F of x is equal to this. And I want f of -3. So we're going to plug the -3 here so for the x and square it. All right. And so this is going to become equal to 2 times -3 squared minus 1. The -3 squared it becomes a positive 9. So you get 2 times 9 minus 1. 2 9 is 18. 18 minus 1 is 17. Answer is this 17 right here. Very good? But okay? You have 2 more pages. Let's go. Finish out the functions thing. 7:30 already. We started late still now, don't it? Because of the rain. Started very late. All right. Let's continue. This one says, they show that mapping diagram. It said the arrow diagram above describes what? So there are some factors business and some multiple business. Let's see which one it is. So you're mapping 2 to 8. 8 is a multiple of the 2. And 10 is a multiple of the 2 as well. 3 to 9. The 9 is a multiple of the 3. And the 4 map to 8. The 8 is a multiple. So these over here are multiples of these. All right. So the y's are multiples of the x. All right. All right. All right. Maybe that way around. Well, the x is a factor of the y then. X is a factor of y. See here? X is a factor of y. See there? X is a factor of y. That's it. Next one, they give the same information. But look here. Look. Same graph, you know, same data, you know, but whether they reverse it. You reverse the values. So you see the 8, 9, and 10. Switch it around and make it the domain. And the 2, 3, and 4, switch it around and make it the range. You see that? Same values. What's the relationship now? These now are factors of these. So the y now are factors of the x. Let's see if that is there. Nope. Well, the x are multiples of the y. The x are multiples of the y. The x are multiples of the y. See there? X are multiples of the y. So they switch it around, guys. They switch it around. So first was a factor, now it's a multiple. See? So trying something. They're trying something. Make sure you look at it and get it right. All right? Don't swap the answers, guys. Look at the diagram. Make sure you're answering the right question. Same thing, you know. So look alike. One question is a factor, the other one is a multiple. So you have a look which one you have. Over here now. They give us this and they ask us which of them is represent this inequality. Let us focus on it. First, the critical values are -2 and 4, and you want the x is between them. X is between them. So there is no equal on the -2. So you're supposed to have an unshaded circle on the -2. There's an equal on the 4, so you're supposed to have a shaded circle on the 4. And you want the region between them. -2 to 4, region between them. That's what they're looking for. Which one is that? The last one. That's the last one. Want to go to that? All right. Since we're on this, let's do a combination. Let's do a couple of them and you tell me which one they are, right? All right, we don't know what's coming on the exam paper. Let's do a couple of them and you tell me what they are. Let's do a couple of them down here. And tell me which one it is. Tell me which one it is. What's the inequality for this one? The -2 and the 4 again. What's the inequality for that one? What's the inequality for that one? Less than 4, greater than -2, don't it? Agreed? What's the inequality for this one? -2, 4. What's the inequality for that one? -2 and 4. A between them. Greater than or equal to -2, less than or equal to the 4. What go with that? What's the inequality for this one? -2, 4. What's the inequality for that one? Less than or equal to the x, but less than 4. Agreed? All right. Just for now. Let's go again. What's the inequality for this one? What's that one? So you're going to the right of this and to the left of that. What's that one? So this one, you're less than the -2. So it's x less than -2 union x greater than 4. That's what that is. See that? Very good. What's this one? What's this one? -2 and 4 again on the number line. What's that one? What's that one? This one is x less than or equal to the -2 union x greater than the 4. See that? What's this one? -2 and 4. What's that one? X less than the -2 union x greater than or equal to 4. What's this one? Two of them shaded now. This is 4 again, and this is -2. X less than or equal to -2 union X greater than or equal to 4. All right, those were number lines. Get comfortable with them. All right, look at this one now. Which one is this? The one on the circle on the one is unshaded clearly. See there? It's not shaded. And we're going to the left. Which one is that? Which one is it? This one, don't it? That's less than 1, no, sir? Less than 1. All right. Good. Good. All right. We have these now. So we'll finish and take a break. Sorry, guys. We're going to go a little bit later tonight because we started late because of the rain. Start about an hour late, right? We're going to go a little bit later. This one says they give us two questions on this graph. It says the maximum point on this graph is what? Right here's the maximum point, don't it? Right here's the maximum point, no sir? That is the maximum point. X value is 2, Y value is 4. 2, 4. Maximum point is 2, 4 right here. Easy question. Next one. Equation of the axis of symmetry. Axis of symmetry is a vertical line through here, don't it? Let's draw it in blue. Axis of symmetry is a vertical line that passes through this apex point. And it passes through where the x value is 2. And so the line is x equals 2. Vertical line carries an equation, x equals a number. So it's x equals 2. See it here? X equals 2. Don't give it away, guys. Vertical lines carry an equation, x equals a number. Like the y-axis. The y-axis is x equals 0. So vertical lines like the y-axis is x equals a number like the y-axis. Horizontal line is a line y equals 0. Next question. The values of x, the same graph, you know. So you see, they give this same graph on multiple papers and ask different things. So here now they're asking the values of x at the point where the graph intersects y equals 0. Look, y equals 0. So I just wrote it for you. Y equals 0 is actually the x-axis. I just wrote it for you. So I want to know the values of x where it crosses the x-axis. So it's talking about these 2 points here and here. 0 and 4. X equals 0 and x equals 4. It crosses the x-axis where y equals 0. 0 and 4. So this question answers 0 and 4. X equals 0, x equals 4. This is it, where the graph crosses the x-axis. 0 and 4. Same graph. The values of x where it crosses the x-axis. The same question. See, instead of y equals 0, it's the x-axis here. So same question. Same x equals 0, x equals 4. This and this is the same question. This is how they set it on a different paper for the same graph. They set this graph on multiple papers, this same graph, asking multiple things. What else they ask? Okay, which of the following is the equation of a straight line? I think we did this question already. This one. Let's move from that quickly. We did this one already. Gonna take a 10 minutes break after we stop, right? 10 minutes break and then we get through the last topic. And a lot of questions on the last topic, you know. I'll go through them quickly. So we just have to do it. Just have to do it. Because it's already minutes to 8. Just have to do it. All right. If you have to leave, you can leave and then catch the video because I'm recording it. If you have to leave, then, you know, like you're going far, you might have to leave. It's the reason why we started late. All right, but we just have to finish this thing. All right, let's go. It says, which of the following, we can't put it after tomorrow because I really want to do that activity tomorrow. So we can't put it after tomorrow. We'll just finish it tonight and tomorrow we'll move on to the next thing, right? Which of the following set represents the function f of x equals x cubed plus 3. So basically you want to test values. I want to see which of these values work on this function, right? So it's just like saying y equals x squared plus 3. So this is a process of elimination. When the 3, 0, 3 works for all of them. So let's see what the 1 maps onto. So we can do the process of elimination. So plug the 1 in here, so plug the 1 in there. So when x equals 1, we're gonna get 1 squared. The y is gonna be 1 squared plus 3. So the y is gonna be 4. So you know, so 1, 4 is a point. So you know, so these two valid, right? So this one out of it, and this one out of it. Right? Those two out of it. Let me mark them here. So it's 1, 4. 1, 4 is the point. When x equals 1, the y value is 4. So 1, 4 is the point that you want. So this one out of it. Let me just exit here. So this one out of it, and this one out of it. So it's this and this. Good. So we need to try with the 2 now. So these are the answers either this one or this one now. Let's look at what the 2 gives us now. So 2. So let's see what 2 gives us. So when x equals 2, the y becomes 2 squared. Let's put by this x. The y becomes 2 squared plus 4 plus 3. 2 squared is 4. 4 and 3 is 7. So this is 7 right here. So this one is wrong as well. See that? But this is giving us 5. So the answer is the last one. The answer is the last one. We'll get the 7. So let's say we get the 1, 4 and the 2, 7. Good to go. Our calculation gave us these 2 points and eliminated the others. So the answer is this. So it's really a process of elimination. We don't have to work out everything. All right, next one. This function is that on the domain, the range. The one, the range is the y values. So you see this function x cubed, the graph will go like this, you know. It's good if you know the graph. It basically shape like this. It go like so. That graph goes like this. Pass through the origin, and it goes like this. Something like that, the graph of x cubed go, right? Y equals x cubed. You get me? So there's no chance of any repeat value, like a curve like that, or a curve like that. There's no chance of a repeat value. It's called an odd function. It's called an odd function. So anyway, you don't worry about that. So basically, which are these now? When you plug these values in there, you're getting these y values, the y values. It's the last one, you know, because if I put the negative 2 in here, the negative 2 is going to map on to negative 2 cubed, which is negative 8. Negative 8. I'm done already because this is the only one with a negative 8 in it, matching this negative 2. So this is the answer. That's it. This 2 is going to give me this 8 out here. So this negative 1 is going to give me this negative 1. This 0 is going to give me 0. This 1 is going to give me 1. And as I said, this 2 is going to give me this 2. So the answer is the last one. But the proof is just one value. If you plug negative 2 in there, that's what I'm going to get. 2 maps on, negative 2 maps onto negative 8. Negative 2 maps onto negative 8. And that is it. This one now, look at it carefully now. This is x squared, and this is negative x squared. But be careful now. You're not squaring this negative, you know, guys. It is not negative x squared you're doing, you know. So you're not squaring this negative. All right? So what is going to happen? What's going to happen here is that all your value is going to be positive. It's going to be negative. You have to be careful with this one. And this one kind of tricky, you know. This one is tricky. So watch this now. The negative 2 is going to map onto minus negative 2 squared, which is going to be negative 4. All right? All answers are going to be negative, you know. All answers are going to be negative. Because this squared term can only be positive. And I put in a negative on it. You see the negative 1 and the 1. You see the 2 going to give me negative 4 as well. If I put 2 there, the 2 is going to map onto negative 2 squared. which is going to still give negative 4. See that? So the 2 give negative 4 and the negative 2 give negative 4. Then if I put in the ones now, the 1, the negative 1 is going to map onto negative 1, negative 1 squared. That's going to be negative 1. And the positive 1 is going to map onto the same thing, minus 1 squared, which is still negative 1. And the 0 is going to map onto minus 0 squared, which is just 0. So you see, these are the only values. If you look at these, the only values you're having are 0, negative 1, and negative 4. That is your range. You have to be careful with this one, guys. This one can trick a lot of people. So the answer is this one. See that? Those are the only values. Put the negative values first, the smaller values first. Negative 4, negative 1, and 0 are your only output values. See that? Because negative 2 and 2 give you negative 4. 1 and negative 1 give you negative 1. And 0 gives you 0. So your range is this. Now remember the question, guys. Now remember this one. You have to remember this one. All right. A lot of people can put this as the answer and get it wrong, you know. Or maybe even this. I think a lot of people can put this as the answer and get it wrong. That is not correct. The answer is this one. Be careful. Be careful. Be careful. I think we have 2 pages left. All right, we're done. These 2 pages and we're done. All right. This one now says, which of the following is a linear function? Pay attention. Just finish a page and next one. Finish a page and next one. Let's finish this page. Which of these is a linear function? First, these 2 not linear. So none of those is the answer. All right? So suppose you might be thinking this one or this one, because both of them linear. But the thing is, this one is not a function. Why is it not a function? Because it fails a vertical line test. Remember, the vertical line test is what you use to decide if you have a function or not. If you draw a vertical line on this line, a vertical line cannot be a function. A graph of a vertical line cannot be a function. Because the vertical line crosses it at an infinite number of points. See that? That we call it the V-line test. V-line test is what you use to determine if you have a function or not. This failed. It failed because it crosses it multiple times. It crosses at an infinite number of times. Any graph that has a vertical section cannot be a function. See that? This one is a function, you know, but it's not linear, it's a curve. You see that? Because a vertical line test would pass this one. That's a function, but it's not linear. So this one is a non-linear function. It's a non-linear. Because it's not a line, it's a non-linear function. It is a function, but just that it's not linear. See, if you draw a vertical line on it, it crosses at only 1 point. That's why you do the vertical line test, you know. The vertical line must cross the graph at only 1 point. This one also is a function. That's a quadratic function. You must know that one. A vertical line on this will cross only 1 time alone. A vertical line on this graph can only cross it 1 time. So this one is a non-linear function as well. It's actually a quadratic. A non-linear function. This one is a non-linear function. So this is a function. If we do the vertical line on it, it crosses only 1 time and it's a line. So it is a linear function. See, if you put the vertical line on it, it crosses it 1 time. So this one is a linear function. This one is your linear function. It is a line and it is a function. So this is the answer, guys. This one. That's your linear function. This is a line, but it is not a function. So this one that they gave us is a line, but it is not a function. They're asking us for a linear function. All right. Over here, which of the following represent a function to the vertical line test? The vertical line must cross the graph at only 1 point alone. Let me show you why these fail. These three fail vertical line tests. Three of them. Three of them fail a vertical line test. Look, this one over here is the first. If I draw a vertical line here, it crosses this point and this point. Those 2 points are on the function. That's it. Your function can't have any vertical section. So the V test fail. V line test fail. V line test is failed. So it's not a function, right? This one also not a function. Can I see these 3 points are on a vertical line? If I draw a vertical line down here, it crosses these 3 points. It's on a function. Again, V test failed. V test failed. Again. Same thing with this one. These points on this function are all on a vertical line. So if you draw a vertical line through this function, these 3 points will be on that vertical line. So you see, the V test fail again. So that's why those are not functions. So this one now, any vertical line I draw can only cross the graph one time. One time this so. One time this so. One time this so. One time this so. Any vertical line I draw can only cross the graph one time. Can only intersect the graph one time. See that? So V test passed. V test passed. That's why this is a function. So to determine if you're a function or not, to do the vertical line test. So that is a function. But good? Online, everybody understand that? Online, everybody good?
Yes, sir.
Yes, sir.
All right, good. Next one down here. Which are the following value? What is the x value at the point of intersection of the system represented by the function? Oh, basically just want the point of intersection of this and this. That's what they want. All right, let's see. What is the x value of the point of intersection for the system represented by this function? It's like you have two lines, you know, like you have y equals 3, and you have y equals 5 over 2x plus 1. That's what you're solving this. You're solving this equals this. See that? Like you're solving them simultaneously. That's what I mean by the solving intersection of a system of system of lines or system of functions. So the y equals 3. So you can take the 3 and put it just over the y. I can put this equals this. Anyway, take it and put in 5 over 2x plus 1 equals the 3. This equals 3. Because the y value is 3. And solving this for x. That's what it is. So I'm going to carry over this first and get 5 over 2x equals 2. Multiply by 2 and get x equals 5x equals 4. And then divide by the 5. X equals 4 over 5, which is 0.8. Same as 8 over 10. 0.8 right here. And then we're going to take one last question and then we'll break. This one says, a parking lot charges $1. It's like it should have been in the consumer part of the paper. Plus 0.25 for every hour or part thereof in which a vehicle is parked. A function CH that represents the cost for parking. All right. So I'm charged $1. That's a fixed charge. Plus 0.25 for every hour. So basically it becomes 0.25 times H. So it's 1 plus 0. See there, 1. Hold on there. Let's read it again. I'm not seeing the answer here. So let's read it again. A parking lot charges $1. A parking lot charges $1 plus $0.25 for every hour or part thereof in which a vehicle is parked. Function CH that represents the parking cost. Oh, see it right here, man, $1. plus 0.25 times H. I didn't see it. I didn't see it. I didn't see it. $1 is a fixed charge, and they're charging 25 cents for every hour. So this is the formula right here. That is it. Straightforward. All right. Then we break. Let me see how much pages this we have there. I don't think we have a lot of pages to do for this one. We're going to fly through this part. We're going to fly through this part. A lot of blank page and one question on a page. See? One question. We're going to get through this quickly. See, one question on this page, one question on this page. This is one question again on this page. One question over here, two questions over here. We're going to get through this quickly. Let's take a look at 10 minutes break. And then we'll come back and knock off this quickly. And then we're done. All right. 10 minutes break. I think we can finish this in maybe half an hour or less. Let's take a 10 minutes break and then finish off with this. 10 minutes. 10 minutes break. Let's start the clock. 10 minutes. All right, guys, one moment. One moment. All right. Ready again. Online, can you hear me? Can you see the screen? Are we back?
Yes, sir.
All right. Can you hear me? Not hearing anything. Can you see the screen? Hello? Hold on a second. Hold on a second. Something is wrong. Not hearing anybody.
Yeah, we can hear you.
Can you hear me? All right, it's cool. All right, one last push. Let's do this. One last push. Finish this thing. All right. I know you're gonna see a lot of these questions in the exam. And if you come with minor changes, you want to be able to do them still. All right, let's go. First question here says, under the translation, under this translation, what is the image of this point? So all that is happening is that this translation is moving this point. So it's quite simple. This point as a vector is 3, -5. And the translation, you're adding this to it, which is 2, -3. So the 3 and the 2 is 5. And the -5 and the -3 is -8. So it means that this point is going to go to the point with these values, which is 5 - 8. Let's use a column vector to do the calculation. So the answer is 5 - 8. Could I just add this value to this? But the translation is going to move this value by 2 to 5 and move this -5 by -3 to -8. All right, that is it. Next one, similar question. Under the same translation, what's going to happen to this point? So we can just do it fast now. This point is going to be moved by -2. So -2 move on the -5 takes us to -7. This is the only answer with a -7 on it for the x. So the answer is this one. The 3 is going to be increased by 3 with this 3. 3 and 3 is 6. That's why the 6 right there. That is the answer. All right, nice and easy. This one, the image of this point under this translation, same thing again. This point is going to move by 3. So basically, is -2 plus 3 becomes 1. This is the one answer with a 1 on it for the x value. So the answer is this right now, you know, this. Or this 3 is going to be moved by 4 units. 3 and 4 is 7. See there, the 7. That is the answer. This question is easy. Come on, come on, come on. I've started. Next one. This one says the image of this point under translation is this point. What is the translation? In other words, how much does this move by to get to that? It's -6 now, -6. We can set up this way. The point P12, the point P12, and put a point P there so we can see it. So the point P12 plus a translation, let's call the translation AB. So you don't know it and it is AB. It's going to be equal to P prime, which is -5, 4. I tried to find this. So you can, to find this, you can basically subtract this point over here. Right? And so TAB is going to be equal to the P prime, which is a -5, 4, minus the P, which is a 1, 2. Can set up like that. So you see, become -5 - 1, that's -6. Let me shift these over. Let's do it like an equation so we can see what is what. That's -6, and then 4 minus 2. 4 minus 2 is 2. 2. So that's size 6. Not there. Hold on, I make a mistake somewhere. Hold on. Oh, this is -4. This is -4. This is -4. Not 4. This is -4. -4. So this becomes a -6. This becomes a -6. -4 and -2 is -6. We could look at it, you know, you could look at it as how much does this move by to get to this? You move by -6. How much does this move by to get to this? You move by -6. So it's -6 is the answer, right? But this is also to show you some calculation if you had to calculate it. But this question don't really need no calculation. You can look at it and see it. But the answer is -6. All right, next one. So this is the same question. This is how they put it on one paper. This is how they put it on another paper. But it's the same question. It said, what transformation maps PQR onto P prime, Q prime, R prime? That's this one onto this one. And the same thing. This one onto this one. It's a reflection, but to confirm it's a reflection, we check the orientation. PQ to Q to R on this object is this way, anti-clockwise. P to Q to R on the image is the opposite way, clockwise. When orientation is reversed, we have a reflection in a line. So the transformation is a reflection in a line. That's what it is, a reflection in a line, reverses orientation. Same thing happening up here. This is the object and this is the image. Let's use the red again. This is what they gave us a different paper. P to Q to R is this way. And P to Q to R on the image is the other way. The orientation is reversed. Orientation is how the letters go around the object alphabetically. So the orientation reversed, so we have a reflection. We can literally look at it and see the reflection. All right, we just want to make sure we do that clarity check by checking the orientation. When orientation reverse, you have a reflection. Reflection is the only transformation that reverses orientation. Reflection in a line is the only transformation that reverses orientation. This one now. This one says, in the diagram above, CD is the image of AB. After what? So you can look at it this way, you know. The CB is the image of AB, So AB is the object. This is the image. So the A map to C and the B map to D. You have to be careful now, right? So it means that this point map to this point and this point map to that point. That is a reflection again. That's a reflection in a line. The line is halfway between the points. So it's a reflection in this line. And now, if I say this distance from this line is the same distance. Look at this point B, same distance across here. So the reflection in the y-axis. Reflection in the y-axis. See there? Y-axis reflection. That's a y-axis reflection. Sometimes simple things are harder to explain, but that's a reflection in the y-axis. All right, that is that. All right. I want to know a reflection on the y-axis, guy, because image distance is equal to object distance. If this is the mirror line, see that this distance to the mirror line, that object distance is equal to this image distance. And this object distance to the mirror line is the same distance here, so to the image. Because this point map to that point, this point map to that point. Just to make that point there. It's a reflection when image distance equals object distance from the mirror line. The mirror line is the y-axis. All right. Next question over here. It says, this is the line y equals x. The diagram shows the line y equals x. What is the image of the line y equals x when it is rotated anti-clockwise about the origin to an angle of 90 degrees? So we take this line, rotating it about the origin, about here, anti-clockwise 90 degrees, you're gonna end up with the line like that. The line is gonna end up here. And you rotate it about this point. And you rotate it 90 degrees, such that this angle here is 90 degrees. This line is a line y equals minus x. That's the line y equals minus x you're gonna get. Y equals negative x is that line. All right? That's what we're getting. Y equals minus x. That line is y equals minus x right here. And I've seen them set the same question where they give you the line y equals minus x now. And I ask you the same thing. They say, what is the image of y equals minus x when it is rotated anti-clockwise above the origin through 90 degrees? All right, so you have this line, I'm gonna rotate it anti-clockwise again. Gonna get by the original line. Okay, you take this now, you're rotating it this way, anti-clockwise, 90 degrees. You're gonna get back this line now. You're gonna get back the y equals x line. Because this angle now, this is a rotation of 90 degrees. This angle here is 90. You're getting back the line y equals x. So the answer now is y equals x. So I've seen them do that. One question they give you y equals x, and you rotate it 90 degrees. Other one they give you y equals minus x, and you rotate it 90 degrees. So you get the other line. Those two lines are 90 degrees apart between them. Nice and easy. I'm gonna finish this part quickly in this section. This one says, shows a translation. So you're going from this one to this one. All right, and they say, in the diagram, translation which maps AB to A prime, B prime represented by which one of these? You need to know how many units to the right and how many units up it goes. So we're using this point to this point. Let's show it in red. All right, let's show it in red. So this point to this point. So these are the x values. So clearly, you go across by 2 units this way. From 2 to 4 is 2 units to the right. 2 units to the right. So you know in the matrix, you have a 2 up there. So. And then from 4 to 6, you say you go up 1 unit. You go up 1 unit. Up 1 unit. All right? So you have a 1 right there. So that is the translation. Hope everybody understands that. The majority or so. So you go across from here to here, 2 units to the right. Okay, you go from an x value of 2 to x value of 4. And then you go 1 unit up. So you go 2 to the right and 1 unit up. So it is 2 to the right and 1 unit up. So that is the translation matrix 2, 1. Right here is the answer, 2, 1. Nice and easy. Nice and easy. All right, next question. This one is another translation again. It says, in the diagram, translation which maps A, B, C onto A prime, B prime, C prime. This was on a recent exam paper. Was on our old exam paper as well. So going from this one to this one. We only need to see what happens to 1 point. Don't complicate it. Look what happens to 1 point. So for example, look what happens from C to C prime. How many units left? You go and then how many units up. So going 1, 2, 3, 4, 5 units to the left. That's a negative 5. So in your translation matrix, you start with a negative 5. And how many units up? 1, 2, 3 up. Okay, I go up now. That's a positive 3. A positive 3. So I put a 3 right here. So that's a translation matrix. Why is it negative? Because we're going to the left. Going to the left. If you ever have one where you go down, then the y value will be negative. The y value will be negative. All right? So remember, if you go to the right, your x value positive. If you go up, your y value positive. If you go to the left, your x value negative. If you go down, your y value negative. All right, so this one is negative 5, 3. Well, the negative 5 kind of dull on this one, but I think this is the one with the negative 5, 3 on it. Let me make this a little brighter. I think this is the negative 5, 3. This is negative 5, negative 3. which is wrong. -5, -3. This is 5, 3. Or that is 5, -3. I'm going to make this be -3, 5. And mark this as my answer. All right. All I know, the one with the -5, 3 is the answer, guys. It's kind of dull. I can't see the values so clearly, but it is the -5, 3 is the answer. All right. I got 3 units to the left, 5 units up. That one is that. This one now. Item 58 refers to the following diagram. That's an enlargement. This, that, and that are straight lines. Triangle ABC is mapped onto A prime, B prime, C prime by an enlargement at the center O. What is the scale factor? The scale factor is the multiple by which it grew, by which you grow the object. So this side, for example, on the image, an object was 1. It is now 2. So it has been multiplied by 2. So the scale factor is 2. Simple as that. The length has been multiplied by 2. So the scale factor is 2, +2. It's a +2. Why is it +2? It's positive because the image and the object point in the same direction. Like, for example, C to A is pointing up. And the object C to A is also pointing up on the image. So it's a positive scale factor, +2. If you were pointing in opposite direction, the scale factor will be negative. In addition to the scale factor, doubling the side, doubling the length on the object, the scale factor also doubles the distance from the center. So for example, the distance from the center O to A has been doubled to A prime. So this distance has been doubled because the scale factor is 2. So that's another thing that scale factor does. Double the distance. Since scale factor is 2, it also doubles the distance from the center of the enlargement. So scale factor is this 2 right here. Don't put -2, you know, don't put -2. Don't put -2. And if I set the question, guys, where this becomes the object and this is the image, and the enlargement goes this way, the scale factor is going to be a half because it's now half what it was before. Good? So them change it and put the prime on this one and make this one become the object and this one become the image. The scale factor is going to become a half. Look out for a change like that. Look over here now. This one says, item 58 refers to the following pair of similar triangles. The length of MO in centimeters. The ratio of corresponding sides are equal in similar triangles, right? So look at this, it's very easy. So they're asking us for MO, which is this length, right? MO. Quite simple. From this to this, you have half the length. So from this to this, to MO, again, you have to half this 7, half the length. Half of 7 is 3.5. You have to half the 7. See? From this to this, you realize that they're half the length. So from this to this, they're also going to half the length as well. So this is going to become 3.5, half of 7. Half of 7. Let me put it here. Half of the 7, which is 3.5. Because they applied a half of 6 to get 3. That's all we have to do. So this is 3.5. The ratio of corresponding sides are equal. So since this was half, this is also half. And this side is also half to get this side. Everything is consistent. Down here, similar thing. Similar triangles again. If the area of this one is 20, all right. So the area now is something different now. Everybody have to pay attention to this now. Watch this now. Where area is concerned, area of image is the scale factor squared times the area of the object. You have to remember this now. Area of image is k squared times area of object. All right. So ready now. Question says, triangle ABC, that's this one. The area of that is 20. That's the area of the object that just gave us. Area of the object. We'll treat this as the object and treat this as the image, right? So they're telling us that the area of the object is 20 centimeters squared. What is the area of the image? That's a small one. First, what is the scale factor? From this to this, you're applying a half scale factor. So the K is a half. So you're half in the size. So the K is a half. I want the area of this image. So the area of the image one, which is what they want, the area of the image one, is the scale factor squared. When you square this half, square the half, you're going to get a quarter. If K is equal to half, then K squared is a quarter. So you put in a quarter right here for the K squared and multiply by the area of the object, which is 20. 20. So this becomes 5. A quarter of 20 is 5 centimeters squared. The answer is this 5. Don't put 10, you know. Don't put 10. Now, because the sides half means that the area is going to be half. No. That's a common mistake people make. Right? When it comes to area, is a square relationship, K squared. This is what you all need to remember. Once there's a change in size and a scale factor happens, then the area of the image is the scale factor squared times the area of the object. I can't go through explaining it now. You just have to know it. So the area is 5 quarter. For the scale factor is a half. From this to this, you apply a factor of a half. That is a K. So you put a half, square the half right there. So multiply the area of the object, get the area of the image. But understand that? Online, nobody go to that?
Yes,
But okay with that online? All right, good. So here, remember the square relationship, all right? That finishes that one. I'm going to get through this quickly now because like one question on the page. Look at this one now. Gives us this diagram here, as you can see. As I said, refer to the following diagram which shows triangle double XY, double prime, X prime, Y prime, Z prime, and then the double prime one. So you have the original one here. They have the image of this, which is the prime one, and you have the double prime one. The double prime one, I guess, is the image of this, right? Let's assume that that is the case. And it says it undergoes a composite or double transformation. Okay, double. So like you go from this to this first, and then go from this to this. Double transformation. All right. So what is a double X? So this is the original object right here, you know, this. Then this is the first image. That one. Then this is the final image. So you know an enlargement took place, right? All right. Question says, what sequence of transformation map the original double XYZ to double prime to the double prime one? What two transformations took place? Let's look at it. So we're going from this one to this one first, and then we're going from this one to this. All right. Let's figure out this to this first. All right. Looks like a reflection, but we have to be sure. Looks like a reflection in the y-axis right now. Because this go to this, and this go to this. Yes, it's a reflection. And then this go to this, and then this go to that. It's a reflection. You might think it's a rotation. It's not a rotation. I'll call it W, X, Y, Z is this way. Clockwise, watch this now. W, X, Y, Z. Is the other way the reflection? Yeah, it's a reflection for true. See it? Other way. So you know it's a reflection. See that? So it's not a rotation. I think I said the wrong thing a while ago. It's not a rotation, it's a reflection. Because the orientation is reversed, right? So that confirms that it's a reflection. So if you think it's a rotation, you check the orientation. So when the orientation is reversed, you know it's a reflection, right? Oftentimes, a reflection and a rotation can look alike. To make the distinction, you check the orientation. If the orientation is reversed, you know it's a reflection. So you know it's a reflection here first. A reflection, right? First thing is a reflection in the y-axis. That's what you have first. Then how do we go from this one to this one? Clearly, it's an enlargement. And the scale factor is a half. For this length, you half it to get this length. So the scale factor is a half. The next thing you want is the center of the enlargement. So you can find the center by joining corresponding points like W to W prime, extend it back, pass to the origin, and can maybe go, Y to Y prime. These two, extend it back, then pass to the origin. So that's an enlargement. The scale factor is a half, or you half the size, and it's positive. I know it's positive. Because the image and the object point in the same direction. So for example, if you look at it, X to W is this way on the object, this way. X to W is still that way. So once they are pointing in the same direction, scale factor is positive. And this is the center of the enlargement. So it's an enlargement of scale factor half about the origin. So the combination then is a reflection over the y-axis followed by an enlargement of scale factor half about the origin. Let's go and look for that now. Let's go and look for that. So it's not a translation. So okay, X out this one. Not a translation. X off this one. Do have a translation. So it's a reflection on the y-axis followed by an enlargement, center the origin, the scale factor of half. This is it. This is the answer. Let's try this one. It's not a rotation. So this one out of it, right? We said it's not a rotation. It's not a rotation. We said it's not a rotation. This one said an enlargement of scale factor half followed by a rotation. There was no rotation. See that? So the answer is that one right there. B is the answer. But good online with that. But okay. You guys are okay, right? All right. Next question down here. Down here says item 56 refers to this, the transformation. This looks like a rotation. What type of transformation took place? So we'll go from this one down here, so up to this one up here. So let's look at it. So OQ, for example, is horizontal, and O prime, Q prime is now vertical. So like you rotate it up this way, about this point. At an anti-clockwise 90-degree rotation, you know. Look at another side. This PQ pointing up this way was vertical. Q to P then. Q to P is now this way, horizontal, pointing this way. So it's like I take this arrow, and you rotate, and you rotate it down this way, 90 degrees to get this one. All right, just that you rotate it about this point. That's all. So that's a anti-clockwise. Because you're going this way, rotation is that way, right? So anti-clockwise, 90-degree rotation, because this was horizontal and it's now vertical. So the rotation is 90 degrees anti-clockwise about this origin. So it's an anti-clockwise 90-degree rotation about the origin. Let's look for it. All right. All right. All right. Why am I saying all right? Because I've been telling you guys about this positive and negative rotation business. Remember? See it here now. Been telling you about it. Remember, guys. See it? So these two questions is one of these are the answer. You know. Or you're gonna know which one it is. Because you have to know anti-clockwise rotation is positive. Clockwise rotation is negative. You have to remember that. Anticlockwise rotation is positive. Remember that. Anticlockwise rotation is positive. You might say, why is the clockwise rotation positive? Why isn't it clockwise? Don't clockwise come before anticlockwise. No, in mathematics, anticlockwise rotation is positive. Anticlockwise rotation is positive. Anticlockwise is positive. Everywhere in math, at every level. In every area in math, anticlockwise rotation is positive. Clockwise rotation is negative. That is a standard. That's just how it is. When you do trigonometry at a higher level, you'll appreciate it more. All right? You'll appreciate it more when you do trigonometry at a higher level. Clockwise rotation is negative. So this rotation is anti-clockwise. See it? So it is a positive one. See it? The positive one. This is the one because the rotation is anti-clockwise. It is the anti-clockwise rotation. I keep telling you guys about this thing in class all the time. So now you see why I was telling you. Because I see it before on an exam paper. So you have to remember. A lot of people won't know whether it's a positive and a negative one to put in order. No, it's 90, but I say, where's the word anti-clockwise? Or where's the word clockwise? You have to know that anti-clockwise rotation is the positive one. So you see them put positive 90 and negative 90. This one is for a clockwise rotation, the negative. But it's an anti-clockwise rotation we have because this is the object and this is the image. Our rotation is up this way. Anti-clockwise rotation we have. Anti-clockwise this way. All right? Write out the word anti-clockwise here. So anti-clockwise. All right. So that is why I kept telling you. I see, and since I've been telling you all the time in class, it's the first time you see a question that applies it. But I tell you in class all the time, right? So because I know that it's possible, that's why I keep repeating it in class. All right, now you see it for yourself. Beautiful. Beautiful. All right. This one says, in each of the following diagrams, A prime is the image of A. Which of the diagrams shows a reflection in the x-axis? Not this. Can reflect A in the x-axis. See the x-axis here? That will come down here, so don't it? Wrong. So this one wrong. The A have to come down here, so again, reflecting the x-axis, it have to come down here, so don't it? Wrong. This one again, if you reflect it in the x-axis, it have to come down here, so wrong. So it has to be the last one. See there, bang, come down there. So beautiful. So the answer is this one. This is the answer. All right. But I could have asked the other questions, right? So let's write what these are. Let's write what these other ones are. But they can say, but the same diagram I ask something different, don't it? Good. So see this one. This one looks like a rotation of 180 degrees about origin. The point here rotate 180 degrees to the point here, right? And this point rotate 180 degrees to the point here. So this should be a 180 degree rotation about origin. This one. Let's write out what they are. 180 degrees rotation. I don't have to say clockwise or anti-clockwise. Can rotate 180 degrees this way or this way. The result is the same, right? That's the thing about 180 degree rotation. With a 180 degree rotation about the origin. That's what this one is. If they should ask you. We don't know what they're asking in the exam. They can give you the same diagram and ask what it is. So them clear answer, which one represents a 180 degree rotation about origin? It's going to be this one. See that? This one, a reflection in the y-axis now. See that? See it? So this one will be a reflection in the y-axis. A reflection in the y-axis. So if in the question, change this and change this to y-axis. Simple as that. Change the x to y in the question and your exam. This is going to be your answer. See it? And then this one now looks like a rotation of 90 degrees clockwise. This one. The point here on this line rotate down to here, so. And the point A right here, so. Rotate down to here, so. You can see the 90 degree angle here, so. Rotate down to here. That's a clockwise 90 degree rotation about the origin. See that? Or negative 90 degree rotation about the origin. See? This one is a clockwise 90 degree rotation about the origin. Remember, we could instead of saying clockwise 90 degrees, we could say negative 90 degrees instead, right? Our clockwise rotation is negative. Or we could say negative 90 degree rotation. And then this is the y-axis reflection that it asks us for. So I'm leaving those on it. Just in case it asks it, change it and ask it. Those will be the answers. Next one. I think this is the same question. Each of the following, OA is the image, OA prime is the image of OA. Which, see there now? See there now? Same question, you know? They don't put the line, but it's the same question. See, that's, you know, which one's a reflection in the y-axis now. See that? See it? Y-axis. So it is this one. See there? Bang. Same thing I just tell you a while ago. This one right here, affecting the y-axis. So I don't have to, this one is x-axis reflection. This one is a rotation of 90 degrees. And this one is a 180 degree rotation. See, it's the same question, it's the same thing, you know. So I can literally just copy these down. Just copy them down and put them in the rightful place, these. Just copy them down. More maths equals better maths. Put them down here. So, and put them in the rightful place, paste. All right, so, well, this one is the x-axis reflection. I'm gonna move this here, so I'll put x-axis. Move this one. Put it here and change this to x-axis, right? Change this to x. Change this y to x. Reflection on the x-axis. Then now the 180 degree, or this one is now the clockwise rotation, right? This one. This one is this. And then this one down here now is 180 degrees right here. There you go. That is that. That is that. Over here now. Soon done, no, soon done. Soon done. I know I'm tired and stuff, but let's push it. We want to get 60 out of 60. 60 out of 60. This one says, this one refers to the diagram of a circle. O is the center of a circle. What is y? Remember, angular center is twice angular circumference, right? Both of them subtended by this arc. The one at the center is twice the one at the circumference. So the y is equal to 2 times the 50 degrees, which is this 100 degrees right here. Angular center is twice angular circumference. Next one. This diagram which shows a triangle within a circle, and it says LM and MN are equal. So these two are equal. It means that isosceles. So it means that the angle alpha as well. And that's a diameter. Diameter subtends 90 degrees. So this angle up here says 90. It says, what is the size of angle alpha? It's 45 degrees. You know? Can you see this 45 degrees? But can you see why it's 45 degrees? Let's look why it's 45 degrees. So angle subtended by a diameter is 90 degrees. That's a diameter. And diameter will always subtend 90 degrees. Or we can say angle in a semicircle is 90 degrees. So this angle right here says 90. And then because these two sides equal, then the angle here and the angle there are equal, right? Those two angles equal. And so if this angle is alpha, then this angle over here is also alpha. And the two of them equal. But because this angle is 90 degrees, them two angles must add to 90, don't it? And if the two of them equal, then 2 times alpha equals 90 degrees. So alpha must be 45 degrees. All right, that is it. So that's why we get the 45. Nice and easy. That's one done. Easy question. Z angles. What's the relationship between angle X and Y? That's what they're asking us in this question. Relationship between X, they are equal. So the Z here is Z. Let's draw in the Z on the diagram. These two lines parallel. This is a transversal line. So it forms these alternate angles that we call Z angles. They are equal. So the angles in the Z are equal angles. Alternate angles. So the Z there, call them Z angles. So the X and the Y are equal angles. They are equal. Same thing here, so same thing. P and Q. So the Z there again. They just change the letters on a different exam paper. So instead of X and Y, they put P and Q on a different exam paper. So again, they are equal. Don't make them tricky by changing the letters. See there again, them still equal. P and Q, equal. Parallel lines again. Nice and easy. Look at this one now. Finishing up now, you know. Soon down. This one says, in the triangle, what's the value of X? Once you see these two little lines, it means that it are isosceles. It means that this angle over here is also equal to 30. So this angle down here is 30 degrees. Total angle in there is 180, don't it? Them two add up to 60. So this must be 180 minus 60. Agreed? Which is what? 120. That's all. So the X is going to be 180 degrees minus 2 times 30 degrees. Let's write it out. Which is 180 degrees minus 60 degrees, which therefore is 120 degrees right here. Nice and easy. Next one. In triangle PQR, P is X and Q is 2X. What is the size of R? It's going to be 180 minus the sum of these two, don't it? 180 minus the sum of these two. Let's just write it. Sum of those two is 3X. That's the 180 minus 3X. That don't need no explanation. Same thing here, so again. In a triangle ABC, them say PQ here, so them say ABC here, so same thing. What's the angle C? Same thing. 180 minus 3X. Bang. Same thing, right? 180 minus 3X. Nice and easy. Down here. Is this the same thing? In triangle, if the angle P formed by two equal sides, if the angle P formed by two equal sides of an isosceles triangle, PQR is P equals X. What is the size of angle Q and or R? So basically what they're saying is this. Watch this now. Easy. These are two equal sides. They form the angle at PX right here. So X. Sorry, X. They're asking us for these two angles down here. Q, P, Q, and R. They're asking for these two angles down here. So let's put them in red. They're asking for these two angles. Let's call them theta. This question is asking us for theta. This question is asking us for theta. See that? Same thing. The total angle is 180, don't it? So what we would say, it is basically 180 minus this divided by 2, no so? Good. Well, let's set it up still. Let's set it up. So we know that 2 theta plus X is going to be 180 degrees. So you're going to subtract the X and then divide by 2. So the theta is going to be 180 degrees minus the X divided by 2. Right here. Nice and easy. What this one says. In a polygon, angle A is X, and angle A and B are supplementary. Supplementary means what? They add to 180 degrees, don't it? Supplementary is a fancy word to say that they add to 180 degrees. What is angle B? So see there, angle A plus angle B equals 180 degrees. So angle B equals 180 degrees minus angle A. Angle A, them says X. So angle B becomes 180 degrees minus X degrees. Supplementary angle means they add to 180 degrees. That's it. So this question is testing your knowledge of the word supplementary. All right. This one down here, you know, says, this item refers to the following diagram, which shows the angle of depression. Remember, the angle of depression down here, looking down, will always be equal to the angle of elevation at the other end because of the z. Remember that? So we know that this angle here is also 35 degrees automatically. Angle of depression looking down equal angle of elevation looking up from the other end. Or you could simply say that the z angles are equal because this horizontal and this horizontal. So this is like a transversal line. All right. Question said that this side is 12. It says the angle of depression is 35 degrees. Hence, we get that angle of elevation is 35 as well. X is 12 meters from Y. That is this 12. What is the height? Y is Z. They're asking us for this height up here. So let's call that height H. Question asking us for H. Opposite and adjacent we have. This is the opposite. This is the adjacent. We're going to use tan. Tan of 35 degrees is equal to the opposite side of H over the adjacent side of 12. Multiply by 12. The H equals 12 times the tan of 35 degrees. Looking for that. See here? 12 tan 35. That's it. I'm showing you something now. Something that I didn't know before, possibly. Right? And since I have tan of 35, I could have put 1 over the tan of 55. So watch this now, if in case I don't know. Pay attention, everybody. Pay attention. The tan of an angle is equal to 1 over the tan of the complementary of that angle. What's a complementary angle? Complementary angles add up to 90 degrees, right? So for example, watch this. The tan, for example, some information, right? Complementary angles. Complementary angles. So like, for example, alpha plus beta, add up to 90 degrees, right? So we know for complement, let me shift this up. We know for complementary angles, the sine of an angle is equal to the cosine of the complementary angles. You know that already, right? So for example, the sine, use some values. The sine of 30 degrees is equal to the cos of 60 degrees. Because 30 and the 60 add up to 90, right? That's a relationship with sine and cos, right? And you can reverse it and say the cos of 30 degrees is now the sine of 60 degrees. You put that in the calculator and work it out. How the tan work now is a reciprocal relationship. See here now, the tan of 30 degrees is 1 over the tan of 60 degrees. That's how complementary angles work with tan. If we want to, we can test it on a calculator. And can reverse the other way around as well. See here now, the tan of any other angle, say 50 degrees, is 1 over the tan of what? 40 degrees. Because 50 and 40 add up to 90. Let me prove it with a calculator now. So it's something important to me. I'm going to show you with the 35 after this. So I'll do it with a calculator and show you. Calculator. The more things you know, the better. All right, the more things you know, the better. Why am I doing that? Because I'm saying if you did not see the tan 35 answer here, you could know that tan 35 is also 1 over tan 55. Because 35 and 55 add up to 90. You understand? That's what I'm basically trying to say. If you don't see this answer, you could look for 1 over tan 55. 1 over tan 55 is same as tan 35. Let's prove it with these now. Watch this now. Watch this now. Put calculator in degrees first. Tan of 30 degrees. Watch this. The tan of 30 degrees is 0.577, right? That's the tan of 30 give us that, right? Let's work this out now. 1 over the tan of 6. Watch this now. 1 over the tan of 60. So you get same thing. This give it the same thing. 0.577. That proves it, right? So the tan of an angle is equal to 1 over the tan of its complementary angle. Remember, the complementary angles are the angles that add up to 90 degrees, right? Good. So I'm saying to you, if you wrote the question this way to find h, and when you look, you don't see this answer, right? You don't see that answer. You could decide to look for 12 times 1 over the tan of 55 degrees. That would still be correct. And we can prove it now. Watch this now. Watch this, we'll prove it now. I work 12 times tan of 55, and so you get actually for the h. 12 times the tan of 35. We get 8.4, right? 8.4. Watch it now. I'm going to do the same thing with a calculation now. 12 times 1 over the tan of 55, 8.4. So I'm basically saying if you look and you don't see this answer, it's because you could look for this one instead. Because you have to know, it's good to know that the tan of 35 is the same as 1 over the tan of 55. All right, complementary angles. All right, enough of that. I'm just giving you that information because I saw something on a paper, on one of the exam papers, where they changed the answer and introduced the 55. Maybe I have it here somewhere. Let's see. All right, let's see if it's here. Let's see. I think it's here now. Look. So look at this one now. This one gives us the same information again, right? It says the tan, it refers to this diagram. Angle again is 35 degrees. So again, we're going to put the 35 degrees in here. Because as I said, let's put it in there from right now. Because remember, the angle outside the triangle can't help you. So I'm going to put the 35 degrees in here from now. 35 degrees. Looking up. This is the angle of depression looking down. Equal angle elevation looking up. We can read on this question. I'll put the 12 on the height. This time, right? Look what I'm saying now. If y is 12 meters from z, that's this. Y is 12 meters from z. Then what is xy? Xy is this now. Let's call this xy. Let's call it d. Let's call it d. We're trying to find d. So we're going to be tempted to use the same 35 degrees, don't it? Watch this now. So this question will show what I was telling you. So when I say the tan of 35 degrees equals the opposite side of 12 over the adjacent side of d. I'm trying to find the d. So what I do? I multiply the d and divide another tan 25, don't it? So the d will be 12 over the tan of 35 degrees. That's all. But this answer is not there. Look at it. See that? See, that answer is not there now. But if you know that this, I see this now, this is same as 12 times 1 over tan 35, you know. So if you know that the 1 over tan 35 is the same as the tan of 55, then you're good to go. So see there, the d becomes 12 times the tan of 55. Because the 1 over tan of 35 is a tan of 55. So this is the answer right here. So that you could also get it by recognizing that the angle up here is 55. Right? You could have gotten it that way as well. By recognizing that this angle is 55 degrees. And then that's a tan equal opposite over adjacent. See that? And I end up getting this answer just the same down here. So I'm going to show that calculation of work with the 55. So we're going to work with the 55. I'm going to say the tan of 55 degrees equals, this over here becomes the opposite now, which is a d. Over this becomes the adjacent to the 55 now, the 12. And then to find the d, we multiply the 55, the 12. So you get the d equals 12 times the tan of 55 degrees. But just to save work, if you had proceed and work it this way, and realize that this answer is not there, then this information to know would be very good, that is equal to that. You get me? And then you could know that this is the answer same way. All right, that is that. So that's why I introduced that to you, because I saw that. This is another question again, same thing. We put the 10 on here, but this time angle is 30. We're going to apply the Z angle in here again. Put the 30 degrees in here. Because of the Z, put the 30 in there. And remember, you know, guys, it have to be an angle of elevation, depression thing, you know. So that this horizontal and this horizontal parallel, right? So let me say this is 10. Sorry, this is 10. And I want us to find the YZ. So I want us to find the YZ over here. Let's call it H again. H. So we're going to use tan again. So the tan of 30 degrees is going to be equal to H over 10. Opposite over adjacent. Remember now that this is the opposite side. This is the adjacent side to this 30 degrees angle, right? Opposite over adjacent. Multiply by 10. So the H equals 10 tan of 30 degrees. Look for it. 10 tan 30, the first one. That is it. All right. So much I have left to do. Soon though, we are done right there. So 2 more pages and we're done. Let's just finish these off quickly and then we're done. Call it a night. This question says, refers to this diagram, which trig ratio is 4 over 8, sorry. So if using this as an angle, let's write it out. The sine of x will be equal to opposite over hypotenuse, don't it? That's so 4 over 8. But the cos of y is going to be the same thing, don't it? Because it's going to be adjacent to hypotenuse. See that? So the cos of y is also going to be 4 over 8. So you're going to look and see which one is there. So those two things equal 4 over 8. Which one is there? Sine of x is there. So this is the answer. Sine of x is there. So another question might put the cos of y as the answer. See that? And to still be correct. This one says, it refers to that. That's a right angle in the triangle ABC. This angle is 30 degrees. And this side is 40. That's a hypotenuse. What's the length of BC? BC is the opposite, you know. BC is the opposite. So I'm going to use sine. Opposite and hypotenuse is sine. So I'm going to say sine of 30 degrees equal the opposite that we want over the hypotenuse of 40. Multiply the 40 here. The opposite side that we want equals 40 times the sine of 30 degrees. 40 sine 30, this is it. 40 sine 30, easy question. Up here. This question gives us this diagram. Now remember now, vertical opposite angles are equal. So the angle over here is going to be 58, if they want that. And then total angle on a straight line is 180. So this angle right here would be 180 degrees minus 58 degrees, right? And so, angle on a straight line. Let's see what they want. What's the angle? What's the measure of angle ABE? Which one is that? ABE. Let's mark it out. ABE. ABE is this one. It equal to this up here, so too, right? It equal 180 degrees minus 58 degrees. Which is what? 140, no, 122, right? 122, yeah, 122. Minus 50 first, and then minus 8 more. Yeah, 122. That is it. Total angle on a straight line is 180. All right. Which of the following angle is equal? Which of the following angles are equal? All right. Which of the following? Same diagram, you know. Which of the angles are equal? So no, say them two are equal. And we also know say them two are equal. All right, let's see. So angle DB, if we'll be careful now. Angle DBE. Let's mark which one is DBE. Let's use a different color. Let's use purple. Angle DBE. DBC, sorry. DBC. DBC is this one over here. DBC. And CBD. CBD B, E. No, them not equal. This wrong, this wrong, this wrong. Then now CBE. CBE, that's here. And ABE. ABE. Wrong, wrong, wrong. They're not equal. They're not equal. This is not equal, equal. ABD now. ABD, that's this one in here, so. ABD, that one in there, so, and CBD. CBD. This one and this one, they're wrong. Those are not right. Those are equal either. So let's confirm that this one is correct. Look like our answer is this one. That's the only one that we're going to check it. I'm going to mark it in confidence that this one is correct. And let's confirm it on the diagram now. Let's see. All right. ABD. 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 ABD is inside this, right? ABD and CBE. CBE. Correct. This one and this one equal. Two of them equal 58. So that one is correct. Next question. A plane flying in a direction of 0.45 degrees and changes course in a clockwise direction to 135 degrees. The angle through which the plane turns is what? So it's like it going so first, right? Going so, bam, 45 degrees this way. It's going on a bearing of 45 degrees. So if I put it in the north line, then this angle is 45 degrees, right? 0.45 degrees. That's where it's going. When you reach right here, so I'll put it back another north line, right? And this is still its direction where it's gonna turn. This is still its direction, you know. 45 degrees. But it turned clockwise to a direction of 135. So the bearing became 135. So if this is 45 and it became 135, means they added 90. So you add 90 degrees to it. So it gone to 135 this way. So it turn and start go so now. Because the bearing is now this 135. 135 is the new bearing. That's the north line. That's the north line. So what angle does it turn through? It turns through this angle, which is 90 degrees. You see that? Turn through 90 degrees. Right? Because right here so it's 45 you know. And now this is 135. So it turn through 90 degrees. So what angle did the plane turn through? Turn through 90 degrees. 90 degrees it turned through. Turn 90 degrees. So you see, it was going this way first. That was its direction. And it's now going this way. Okay, go on a bearing of 135. So it turned 90 degrees to go on this new bearing. That is it. All right, that finishes that. I think we have just this last page. 2 more questions. And we are done. What this one said? A ship sails 8 kilometers due east. Let's draw it out. They go east this way, right? East is this way. Due east means towards the east. Remember the word due is just a fancy word for towards. So it go towards the east. Remember, in a cardinal system, you have north up here, and you spell we across here. So if you go east, you're going south. Always spell we across here. Everybody knows the north is at the top, right? So if you go due east, you go 8 kilometers this way to the right, right? 8 kilometers to the right is east. 8 kilometers this way. From A to B, 8 kilometers. It says it then sails 6 kilometers due north. Due north simply means towards the north. You're going towards the north now. To C, and they go 6 kilometers. Which of the following diagrams best represent the path? This one, looking for this one. 8 to the right and 6 up. 8 to the right and 6 up. Not this. A to the right and 6 up. Not that. Not that. There it is. A to the right and 6 up. Not this. That is it. Last question. It says, a surveyor sets up its instruments 12 meters from the foot of a building. So this distance is 12 meters from the foot of a building. And records the angle of elevation of the top of the building. So it's recording the angle of elevation at this level. So this is the higher level. It's elevating the line of sight to get the angle of elevation, right? It says an estimate of the height of the building is what? So they don't tell us about the height of the man, but we can see it in the diagram. It's 1.6. The height of the building is this overall height, which becomes 1.6 here, so plus an additional height up here that we're going to call H. And see this 12 here, so it is the same 12 here. Same 12 meters on this triangle. So we're going to work on this triangle where the angle is 40 degrees to find the H. I'm going to add the H to the 1.6 to get the height of the building, right? So we're going to work in this triangle first. I'm going to use opposite and adjacent, tan. So it's going to be that the tan of 40 degrees equal the opposite height over the base 12. So the height then is multiplied by 12 over here. So the height, this height H becomes 12 times the tan of 40 degrees. So the overall height then is this H plus the 1.6. That's what they're looking for, right? H plus 1.6. So the overall height is 1.6 plus H, which is 1.6 plus 12 tan of 40 degrees, which is the last one right here. And that is that. All right, guys. All right. So just went through at full bank. All right, all the questions I've set for the past 10 years, we've just gone through. Over 4 days. That's what we just went through. All the questions I've set, well, not for full 10 years, for the past, not 10 years, for the past 14 papers, past 14 exams, which is 7 years. All right, that's what we just went through a while ago. All right, so let's make sure we never skip out anything. You guys should be good. I've been exposed to all of them. So remember, guys, tomorrow we're doing 6 papers tomorrow and 6 papers on Thursday, and they're gonna kill the exam on Friday. Crush it. Come out the exam and say soft with a capital T. All right. All right. And we got through everything. We got through everything. We got through all of them. Yep. We got through all of them. Here it is. Beautiful. Okay, guys. See you all tomorrow. Online good? Online, everybody good?
Yes, sir.
Everybody okay online? Not hearing anybody?
Yes, sir.
Alexander, you good? Kwame. Kwame Barnes. Kwame Barnes sleeping. Hunter Richards. Mark Fagan. Hey, body sleeping online, you know. Body answer. Your body tired. Anyway, so you go. All right, so the video will be there. Well, some of them might actually off. They them gone already. Anyway, all right, I'm gonna end it now. So recording is there for those who missed it. I'll see you all tomorrow. Bye, everybody.